Hi, I'm Chris Short. I'm a senior developer advocate at AWS. I work in open source at AWS now, so off Kubernetes exclusively and onto the entire open source ecosystem. This is a new job for me, but it's going to be fun. So today we're going to talk about burnout, but during the talk, there's going to be many triggering things. And I might not hit on all of these, but as people come in, I want you to read this list real quick. And if any of these situations apply to you, including the moderator, we can make it through this talk without you, I promise. Oh, thank you. I appreciate that. So yeah, here's my trigger warning list because we're going to talk about my real life stuff, okay? And it's kind of gruesome to a point. Trying something new for accessibility purposes, you can get the slides and look at them now and follow along and see all the notes and see what I missed. Because I am doing this from mostly memory. Now, I realize we're in the EU, and this is a US statistic. So, you know, for the EU, it's hard to get a read on burnout because there's a different study in every country at a different time. One thing I did notice is Western Europe has a lower burnout rate than Eastern Europe. I imagine there's some history there behind that can explain it. However, it was like a gradient almost, like good to bad. So be friendly to your fellow Eastern EU people, but so, you know, I needed a number, and I figured, well, the EU's at least 10% more awesome than the US, like easily, okay. So that means about half of us in the room are either going to or have experienced burnout in some way, shape, or form. When I was making this talk, I realized I suffered burnout multiple times. And that's why I put this slide up there. So what is it? What is burnout exactly? That's the only way we're going to figure out how to fix something is to identify it, right? So we feel exhausted, we have no energy, and we feel like we can't do good work. Like, those are three key points. You become, now this is how you act, you become cynical, you have negative attitudes towards your projects. We also experience disassociation from the projects and the people in our lives. This is where things got weird for me. And then ultimately, you feel ineffective. Burnout makes you just feel like you can't accomplish much, even though you're probably being highly productive without even realizing it. In other people's eyes, you just need to ask and kind of get out of your own bubble sometimes. So I originally said even kids deal with burnout, but I'm just going to say everyone deals with burnout because, of course, kids deal with it. We're all humans. I'm going to tell a story now, personal story. Well, this is what my brain looks like when I'm burned out. My burnout manifests its way in 3-4 different ways: anger, anxiety, sadness, or depression. That's like, the more depressed, the more anxious I am, I feel myself getting closer to burnout. That's experience talking. But that was my head before I got a therapist, basically. All right, so burnout, what is burnout plus? It's when you're already burned out, with or without realizing it, while having another event happen that could make you burned out. So open source contributions are something that I know can be exhausting. You know, after reInvent and KubeCon and end of year reporting and all that stuff we need to do, by the point I'm like just so done for the year because I've done like 3 conferences in a row and now it's December and I'm ready to just unplug. So, but you know, you can have an injury that can cause burnout. You can have anything that can cause burnout. As I was just discussing with Sarah, if somebody passes away, death is a cause of burnout for others sometimes. So you have to be careful. And even just a missed opportunity can create, or at least be a exclamation point on a series of burnout events. So I had an early life encounter with burnout plus. So I was in the Air Force from 1999 to 2010. The week before 9/11, Monday, my grandmother died. Wednesday, I was hospitalized with flu-like symptoms. Thursday, my best friend passed away at the age of 20. Here's some headlines from his college at the time. It's really hard to see these words associated with your best friend. It's incredibly difficult to have a friend go through a drug overdose, especially when they were young, because you just sit there and you wonder why. Well, as we slowly put together the picture of his life and what it looked like in the last few minutes, none of his friends were aware he was dealing with shingles. If you don't know what shingles is, I've had it. It sucks. And I'm only 43. It's like supposed to happen to people in their like elder years. It can be a stress-induced thing. So he was 20 years old, as I mentioned. He was a student at the University of North Carolina. And he just got rejected from their prestigious business school. It's prestigious as it is, whatever you want to call it. It was a big deal to him. He worked really hard, and he got rejected. So he went to go blow off some steam. It's a college campus. We don't know exactly what he did. The toxicology report showed us what he did. A lot of drugs, which, okay, fine, it's college, you know. Those are those years. But then he went home and went through his nightly regimen of stuff he was taking for shingles, which included an opioid that put him to permanent sleep. So he never woke up. That's how he died. That's a nice way to go in the grand scheme of things, but when you're 20 years old, having just dealt with a hospitalization of grandmother dying and you're in the military, I was 21 at the time, that was a lot. And I didn't even know it. I didn't even realize it. So, yeah, it bothers me today, but I've had many years of therapy so that I can talk about it now without getting emotional, without becoming angry or anxious or sad. So it's something that needed to be defended, and someone did. So this person is a very important person in this journey just by writing this. I didn't know them, which I think is the best part, so I reached out after they wrote it, and I said, thank you. Then 9/11 happened on the Tuesday after that. Now, as you can imagine, being in the Air Force on 9/11 was really, really weird. I watched the second plane hit the towers live because I was already awake. As Kim knows, I wake up very early in the morning sometimes. And I watched the second tower get hit. And I told my ex-wife at the time, I'm getting in the shower, because we were at my parents' house just coming back from this funeral. I'm going to get in the shower. If they hit the Pentagon, we're leaving, like immediately. And like 5 minutes later, they hit the Pentagon. I was like, okay, we need to get home. I was attached to a unit that provided communications to other units while they were out in the field. All of a sudden, our services became very important because we were one of very few facilities in the US where you could get all the services you need to set up a secure data center for the Department of Defense anywhere in the world. So when we first went into Afghanistan, people were bouncing a circuit off a satellite over Afghanistan to Europe, and then again to another satellite over the Atlantic to the US. So really long chain of technical problems we had to solve there. But my life changed because I felt like the US intelligence community failed us. So what did I do? I dove in. That's what I usually do. I try and fix stuff. So I joined a very exclusive unit, and we did a lot of hard things. And I went back and I recounted all the stuff I did before I was medically separated. And like, these are all major life events. And you can see them happening in my early childhood years, my teenage years, all the way till I'm 30. Like, any of these one things could have been a source of burnout. But that week after 9/11 pretty much took my burnout and turned it into fuel, like jet fuel, basically. And I worked really, really hard, got assigned to this prestigious unit well before I should have been, rank-wise, because they needed expertise like the ones we were providing folks in the field. That's what this unit did. It just did the opposite side. It went out to the places to set up the bases as opposed to being the facility that they reached back to. So I got on the other side of the spear, basically, is what they called it. But I moved around a lot as a kid, all in the southeastern U.S., but I went to 3 different high schools in 4 years of high school in the U.S. Yeah, like not because of discipline, not because of bad grades, just because I moved. So that alone, right, like I was done with high school and burnt out on school, education in general, and most of my family's teachers. So I did this. And I do realize I don't necessarily look like that anymore, but someone did tell me I'm still looking like an Air Force person this morning, so I need to fix that. So let's talk about being a disabled veteran. So in 2003, I had just gotten back from 10 months in the Middle East, and we had to do a hurricane evac exercise. This was like October. So this is the dog and pony show, essentially, of hurricane evacs, which you would think, why do you need to practice a hurricane evac when most of your units actually deployed? Well, there's this thing called the color of money in the US government. If you designate money for a thing, you have to spend money on that thing. And that color of money will never change. And they're like general categories, right? Like, morale-raising things, operational things, strategic things, tactical equipment. There's all this color of money. Anyways, there's even congressionally written laws that dictate the level of disability you are and dictate how to measure a disabled person's part. It's range of motion, pain levels, all these things put together to give you some kind of scale on 0 to 100 of disability. This is the mortality rate of veterans in the US. This weighs on me. The goal is to beat the odds, right? When the VA described me as a disabled veteran, it changed the way I saw myself. Like, I knew I hurt. I knew I felt bad. I didn't realize it was actually permanent until they said, no, really, here's your disability rating. Yeah, everything down to like how you get disability is congressionally controlled in the US. So here's what's actually wrong with me. And to give you an example of how bad the Veterans Administration is in the US, this is the first thing they did with me once I got to a real doctor inside the Veterans Administration system. They wanted to prove that I was actually in pain, as if the records and years of stuff wasn't enough. They took this thermal image. This shows variation in skin temperatures, like on a very, very small level. Like red is bad. White is really bad. So you can see red and white up here and here. What does this mean? These are all inflamed areas due to injury. That's how this camera worked. It's not like mirrored, so it looks like my right shoulder when it's my left, or vice versa kind of thing. But basically, even they didn't trust me after I got to them. So it's like, oh, they had to verify that everything was right before me until they can treat me. So once they saw this, and 3 other students at the time, because I'm always here to help people learn, they're like, we're not going to be able to fix this. This is not something we can just fix. You're going to need treatment. You're going to need lifestyle changes. You're going to need a whole bunch of stuff. So I'm here to testify disabilities suck. It sucks to get them. It sucks to deal with them. I have no days off from pain. I'm in pain right now. It's pretty low, but I'm in pain. It changes the way you think. It can also short circuit the way you think. I don't get any days off from it, period. Me standing here is just a testament to the modern medicine that I got myself out of and started using private insurance to treat my things. So I talked about the VA, how bad it is, how awful it is. I've been through 2 VA disability rating appeals already. I'm about to go through a 3rd. And the first one took 4 years, the second one took 3 years. But I've got a really good plan to help me get, out of burnout here. It's called hiring a lawyer. He's gonna go do that work. Or they, I don't know who they are yet, I haven't called, because I've been putting it off all month because it's that bad of a process. But I'm gonna call a lawyer's office when I get back, and they're gonna do the work for me. Because that's the only way you can do it these days. They've made it so hard for veterans to get any kind of help that you have to have lawyers fight for you if you actually want to be represented well. That's scary. Because normally they just hand you a piece of paper and say, fill it out. And that's it. They don't give you any advice. Their job is to deny you so they can have more money for something else. They're not incentivized the right way to protect people. So, okay, all the statistics aside, this is the one that I'm driving towards right now. US veterans already have a high rate of mortality on average. The disabled veteran mortality rate is even worse, age 67. That's like, it's weird to have stats like that are like specifically geared towards you, about you, and the average age you will die at. So like if I make it to 72, did I beat the odds? Maybe, kind of, right? Like I'm still in that 10 plus or minus window. So that is the daunting number that I face right now. That's 24 years from now, I should be okay, right? No. How far? Never mind. I can't do math. 17 years. All right, so what is burnout plus plus? Being burned out without realizing it while having multiple burnout-inducing events occur all at once. What does this sound like? Sounds like that week before 9/11 and the week of 9/11 put together. But other things can do this. Toxic family members. Buying or selling a home. That is stressful. Really stressful. Global pandemics are tough too, I've heard. We've done that, everyone in here. That was tough, layoffs, all that stuff. So don't learn the hard way. Hopefully that's why you're here, so you don't get burned out. So I did it wrong for a number of years. Like any good person going through the VA, I was like, something's wrong here. And eventually it got to the point where other people were telling me something's wrong here. You need to go see a psychiatrist. It's like, fine. But they were just throwing more and more meds at me. At the age of 31, I was addicted to morphine, thanks to the VA. Actually, I had to go to a hospital one night because I was going through withdrawal and didn't even realize what it was. Had no idea that that would be a problem. They didn't prepare me for a life of opioids, right? Like no one tells you, like this is how your life's gonna be and it's gonna suck and you're gonna have these problems. And yes, the whole opioid crisis is awful and terrible, but I'm a victim of that process correction because now it's harder for me to get the meds I need to just get through the day. So I actually have to use 2 different pharmacies right now, which is nuts to me because the pharmacies in the US, 2 of the big ones, they've been sued for malpractice because of the opioid crisis, and as such, they're not buying as much. And that means I have access to medicine problems. That's anxiety-inducing. Especially when you can go, I take 3 medications that I can suffer withdrawal symptoms from. Even worse. So, going back to the VA, every time I came home with a new prescription once a month. It was nuts. My wife, Julie, she's part of the reason why I'm here today. She said literally, and I quote, "I feel like they're only going to keep giving you pills until you aren't yourself anymore, you go away," meaning you leave the VA, or worse. Okay, fine. I was taking painkillers and anxiety medicines, which aren't really a great mix. They're kind of frowned upon, actually. So I'm getting off of one of those. But I had this perception problem with the world. My glass was always half empty. Didn't believe good things would happen until they actually happened. I always planned for the worst. I needed to change how I thought about the world. All these things. Thank you. But I had no idea how it all worked in the U.S., like actual civilian medical system, because I'd been in the VA for so long. So I had a friend. They were the SIG lead for the SIG I was working on at the time, contributor experience. They knew everything about how to get through to the mental health people in civilian healthcare. She taught me everything I know. Literally, how to find a psychiatrist, how to find a therapist. Those two things are hard. I got lucky with my therapist, did not get so lucky with psychiatrist, so that's why I'm on all the meds I'm on, and some of them aren't good for me. So there's a lot of ways to get to that. But the therapy that helped me the most was called EMDR. There's cognitive behavioral therapy, but there's this newer thing called EMDR, which I don't remember the name of, I'm sorry. But it basically simulates REM sleep in real time. And it uses motion and lights, all that stuff. It's interesting. But I was totally able to do it throughout the pandemic from home. It was really cool the way we did it remotely. You need a psychiatrist that gives you medicine in the US, and you need a therapist. And you don't necessarily need medicine from a therapist, but they're there to talk to you about how you perceive yourself and how to fix that perception. I'm trying to hurry up here. So this is basically how EMDR works. I had read about it in a Wired magazine article way back in the day. I had read about it in another article that my wife handed me right before I went to go pursue this. And luckily, like I said, I hit a home run with my therapist, the first one, because I knew what I needed. I needed to change the way I thought about events in my life so that they weren't so impactful anymore and didn't send me into some kind of panic attack. It's not for everybody. It might not work for you, but at least you know it's out there. This is how you get rid of it. Like, go find your person in life. Someone that's going to be there for you no matter what. That is the current partner I have right now, my wife, Julie. She literally has been there through all of this. I've had to cut ties with my entire family. I started public speaking at the age of 37 in Detroit, of all places. And then we moved up there. Once I stopped talking to my family, we moved to Michigan because it made no sense to stay in North Carolina. And we have the most amazing family network. My son has I have 4 nephews, so he has 4 cousins, all boys, all within 5 years of him. So we're all within this nice little tight area. If there's anything you take away from this talk, take this QR code. There's links at the end of it, all kinds of stuff. But this is what helped me realize I was in burnout, and I needed to figure out a way out of it. Thank you. So these folks, they make a checklist, and they have you do, a little survey, and they tell you, hey, you're probably burnt out, or you have like a moderate risk of burning out, or what the tolerance is. This checklist changed the way I looked at my world, but also made me realize like Detroit was my refuge away from the craziness. I moved up there and left all that behind. I was closer to my daughter, who I had in my previous marriage. I was closer to everything that I loved. So it just made sense. And I now realize, Detroit gave me the chance in 2016 to do my first public speaking event. And now I'm here in Paris. That's pretty cool, right? Like, that's a great story. So you can be a dude from the middle of nowhere in North Carolina, go through very traumatic experiences, and wind up thriving once your mental health is taken care of. So I've been doing great since we've gone through this treatment, and it started back in 2018. And I'd say we got to a completion point around 2022, summer of, where we had finally processed all these big negative events that you saw before I turned 30. We had weeks of therapy for each one of those. So when I get anxious, a number of things happen now. But I can identify when I'm anxious versus when I'm normal. I can identify if it's like too much coffee or if it's a panic attack potentially. It's really cool. But when I get anxious, my blood pressure goes up and my pain levels go up. I have high blood pressure. It's because of the psychological pressure and the physical pain. Period. Those are the only two reasons why. Cardiologist certified. All right. So the best thing about figuring out how your brain works is how to make it stop doing the things that harm you. So accept who you are. Accept the situation that you're in. Don't deny yourself of what you are, right? Like, don't try and trick yourself out of it. If you need help, go get it. It's okay. I know there's a stigma. It still exists today. That's why I'm standing here, though. So thank you to Rejekts. Thank you to all of you for coming to this. I really appreciate your time. You can be forgiving with yourself. You can make a list of things. You know, ever since YAML entered my life, lists are nice. You know, I knew I needed professional help at another level once I made a list of things that were bugging me. It's like, there's nobody that could fix this. So I'm going to jump through the next few slides because I've kind of told you the whole story, but I got my therapist, I got my psychiatrist, we're moving forward. You know, we're doing cloud native things here. But you can get burned out while you do it, so be careful. All right, if you want a list of everything that was referenced in this talk, and I mean everything, it's on the last slide. The link to the slides are there. All those resources help me figure out how to explain burnout, how to do this talk, how to get out of burnout. It's going to be something different for everybody. So there's not one good answer. But if you read all those, I hope you can find your answer. And then I'll go back. So hang on. Thank you all.
Is there any question for Chris?
I will be around.
Yeah, I mean, we gathering in our half an hour downstairs, so yes. Yeah. Okay. So we will be back in 5 minutes to the next session. Okay. Thank you. Thank you so much. have this session with Kunal. He's going to talk about all these struggles in the growth of cloud native projects and how that relates to inclusion and bias, and why not trying to find a way to be kind and have empathy in those projects. So over to you, Kunal.
Thank you so much. Bonjour. Bonjour. Did I say that right? Okay. Well, thank you. Still learning. Thanks, everyone, for joining. Ooh. I should mirror that. Hold on. Display. And mirror. That looks good. Okay. Hopefully that would work. Nice. All right. Thanks everyone for joining. We're going to talk about addressing bias and inclusion and all sorts of things. But my co-speaker Akanksha could not join because of travel restrictions, some visa issues from India. So I'm speaking on her behalf. So shout out to her as well for helping me put this presentation and talk together. Bit about me, I'm Kunal. I work as, I should probably do that later. Kunal, I work as a DevRel manager at Civo, CNCF ambassador. Very nice to be here. I love Cloud Native Rejekts. It's very good. All right, so Microsoft CEO, Satya Nadella, said that there is one trait which is more important than talent or experience. Can anyone guess what that trait is? Yeah, it's important. Empathy. Yeah. So empathy makes you a better innovator. We're going to talk more about empathy. If you don't already know, it's essentially a trait via which you understand the point of view of others, share their feelings, put yourself in other people's shoes. And an important question I have for everyone over here is, if you can just scan this QR code, you don't have to sign up. It's anonymous. So we'll just do a little poll. So the first one is, how many years of experience you have? You can still scan it. Yeah, still over there. It's reading the crowd. Good mix of people. Good chunk of people. All right. Cool. The next one is important, which is empathy irrelevant to software engineers? Yes or no? Oh, you can edit it. You can edit it.
I did edit my response. Okay.
This isn't a survey, it's a test.
I need the dagger guys to keep me. No worries, I did the same.
All right, well, there's still some people who maybe, I hope it's an error, but anyway. The last question is some very nice things to try in Paris, if you can give your recommendations really quickly. I went to an Ethiopian place last night with Duffy. It's really good. Any bread. Present at Rejekts. All right. Disneyland. Not sure we have time for that. They did Disneyland KubeCon thing before. LA, yeah. No, I remember. There was some group like KubeCon Disneyland, something happened.
After LA.
Yeah. All right, cool. So is empathy relevant to software engineers? Many of you said No. It's not irrelevant, meaning it is relevant. I think that is true. The reason, can anyone give me a reason why? Why is empathy relevant? Yeah.
A reason why it is irrelevant or not?
It's the same thing. Yeah.
Empathy is important because
Yeah.
you work with other people in a team.
Yeah. It's very true. Yeah.
You make better software if you understand your users, and you need empathy
Hmm.
to understand users that are not the same as you.
Yeah. That's true. So understanding the users and working with the teammates, there's one very important aspect to both of these things, and that is communication. So coding is about delivering messages to people and machines, and it leads to communication. And forget about tech. Anywhere where communication plays, like anywhere in your life, when communication is an aspect, like empathy plays a role over there. That is ergo why, when you're a software developer, it plays a crucial role. But I've divided this talk in like 3 parts as well. Like we'll talk about empathy for users, obviously for your open source contributors, for leaders, and for teammates. Question, now what is the first step towards solving any problem? Forget about like tech, in general, any problem you want to solve. What is the first step? Understanding the problem, recognizing the problem. So that's what we're going to do. Obviously, I'll do it in a way that developers can relate. So we'll talk about what prevents empathy. So we'll talk about a lot of biases, and feel free to raise hands if you feel like you have suffered from this bias. So the first one is confirmation bias. So this is the tendency to seek out information that confirms pre-existing beliefs or assumptions while ignoring the information that contradicts them. So developers who suffer from this bias may only seek out user feedback that confirms their assumptions about the product, rather than seeking out feedback that like challenges their assumptions. So I have suffered from this in the past. Next one, curse of knowledge. I know everything. Developers who suffer from curse of knowledge may assume that other people have the same sort of like expertise as them, which can lead to products that are difficult to use and understand, and also poor documentation. So if you're contributing to docs, I think being a beginner is one of the best skills you can have because you bring a new perspective. I just put curse on Google Images, so it showed me Voldemort. So it's not really relevant to, it's just, yeah. Anyway, hindsight bias, which is a tendency to believe that events were more predictable after they have occurred. So developers who face this sort of bias believe that the feedback that they get was like obvious in retrospect, even if they did not consider it during the development phase. So they get some feedback and they're like, yeah, I did think about that, but in reality, you did not. Availability bias, which is the tendency to rely on readily available information when making decisions rather than seeking out more comprehensive solutions. So devs who suffer from this may rely on feedback from a small user group and ignore the feedback that is more difficult to obtain. I don't know why Brad Pitt is there. I have no idea. It's yes, Moneyball. It's because of the movie, yeah. Gender bias, we have seen this as well. Unfair preferences against individuals based on their genders. So we know what we're talking about, like not giving platforms to women, for example, or other people, being not very inclusive. One of the main challenges with communities that are gender biased is that it makes it difficult for people who might feel like they are excluded from joining the community, get access to the community. So whenever you're forming communities, try to form it around people who feel like they might be excluded. So yeah, we have all, it's a very major topic. We have all seen this. Cultural bias is the tendency to favor certain cultural norms and overlook those that are from different backgrounds. So developers from different cultures might find their ideas less accepted or understood. And also in your company, there might be like holiday days that would be, So I live in UK now, and obviously UK does not have Indian public holidays. So Mark, our CEO, he was like, yeah, it's fine. You can take Indian holidays and you can skip the UK holidays. It's fine. Just tell the HR people. So that's another good example. Age bias, ageism is it called? Discriminating against, what's the word I'm looking for? Don't want to get cancelled. Experienced older people? Older in age? Elderly. Thank you. Yeah. So this could be like, you know, tech companies who favor like young developers due to the stereotypes about technological adeptness and overlooking older developers for promotions despite the vast experience that they bring. Affinity bias. So this goes on and on. We're really messed up, aren't we? Affinity bias is the unconscious preference for people who share similar qualities and experiences or backgrounds with oneself. So in development teams, it might result in managers who favor team members who have specific similar coding styles, went to the same school, and yeah, that's another one. Status quo bias, which is the preference for existing state of affairs, resisting change for new ideas. So this can manifest in development teams as a resistance to adopting new technologies or methodologies, sticking to familiar tools and processes even when better options are available. A good example for this is platform engineering. It's like very difficult to like one of the biggest challenges with adopting platform engineering is the team is just not willing to explore the change in culture. I think that's one of the biggest ones. Recency bias, which is the tendency to weigh in recent events and experiences more heavily than the earlier ones in decision making. So this might be evident in development when a team overemphasizes a recent success or failure, leading to skewed decision making for future projects or technology choices rather than considering a longer history of experiences like over the years. Can also lead to demotivation, like everything is going nicely and then you do one thing wrong and it's just the motivation goes downhill. So that's not good. All right, we're done. Anyone suffers from any one of these? You don't have to say which one. You're lying, or everyone is lying. No, I'm kidding. So how do we fix it? Let's talk about users, the art of listening, listen to your users, how to apply empathy with users. Creating personas can help. Personas are fictional characters, which you can create based upon your research to represent a different user type that might use your products and your services or your brand in a similar way. In addition to this, conducting surveys, user testing, interviews, analytics, focus groups, so on and so forth. This is a little map that I like to use, which is audience versus actions. So figure out who your audience is, what they need, identify the individuals, consider the context and define their needs, then work on the actions. So what's the best action you can take, which is also feasible, and then creating artifacts. When it comes to teams and working effectively as a team, some of the team struggles like lower team morale, negative work environment, poor communication because of different perspectives, product quality going down because someone mentioned, ineffective problem solving, so on and so forth. These are all the problems and struggles that teams might face if you lack empathy. Conflict resolution is another one. Along with, if we talk about like what are the benefits in terms of having empathy-driven development in your teams, builds trust, communication, creativity, team morale, and in the end, you're overall as a team you're more efficient. Strategies to do it: actively listen to your team members. No question is a bad question, sort of thing. So having an open workplace where people can ask questions, because believe it or not, like some people are hesitant to ask questions because they feel like I would sound, what's a good word? Not smart, right? So no question is a bad question. It's a good culture. Putting oneself in other people's shoes, practicing curiosity. Why is something happening the way it is? Thinking outside the box, practicing perspective taking. You might not always relate to the person, but try to just think from their point of view, and providing support, obviously, when teammates get stuck. This is my favorite part of the presentation. How many of you have come across a code sample which is just the worst thing you've ever seen, and the person who wrote this is no longer in reach, left the company or whatever, MIA, left the company. So if a person leaves the company, that's done. Like, it's not their responsibility. Like, you can't ring them up. Like, hey, you know, when you worked in this company, you wrote this code. Then you can't do that.
It was really bad.
Yeah, it's really bad. So, who has faced this? Yeah, few people. So what did you do? Yeah, you figured it out. Good.
Spent a year figuring it out. It was faster in the end, but it took a year.
Yeah. That's other thing. Like, this is something you don't have much control over because the person has left the company. So things you have no control over in life, don't worry about it. So again, when we talk about thinking about when we have a problem, just think about what the problem is and what do we need to do in order to solve it. And you can't ring the person up or slack them or whatever because they have left the company. So swap the blame for honor. So don't blame the person, but swap it for honor. What I mean by that is, like, leave the code better than you found it. So like an archaeological site. Who are those people who dig up dinosaurs? Paleontologists. Yeah. So they find dinosaurs and then they find like some bones here, some bones there, and then they put it all together in the Natural History Museum. It looks really nice. So what they did is bad code, they made it pretty, and then they sort of like reverse engineered it with what they have, and then they made it pretty for the future generations. So work with what you have with the team, with the tips that I shared before for teams, and leave the code better than you found it because the future people will thank you. And don't forget the documentation. I like to say good writing is simple writing, so keep it simple. Yeah. Last section is for like the leaders, which is this point, very important. Who suffers from imposter syndrome? Yeah, me too. Yeah, so imposter syndrome is nothing like, it's a hot topic, I think. So imposter syndrome, no one invites imposter syndrome. I think we can agree on that. No one is like, I need it, and yeah, yeah. So it just happens automatically. I think we can agree on that at least. And another thing we can agree on is it happens to everyone. It can happen to everyone. Senior engineers, juniors. Tom Hanks also suffered from imposter syndrome. He said it in an interview. So 2 things we have established. It can happen to anyone, and it can happen anytime. So you have no control over it. And again, bringing back to my last point, you don't have to apply this in your life. This is what I do. If I don't have control over something, I just would not stress about it because I don't have control over it. So if I stress about it, what's the best that can happen? Nothing, because I have no control over it. So just think about, okay, this is fine. It's happening to most people. You're not inviting imposter syndrome. Cool. What to do? What can I do? So what I did is sort of like a silver lining. Found yourself in a project where you don't know much about the project. No worries. Great. New skill to add on my resume. Fine. I'll learn it and then I'll talk to people. Because my team has been really empathetic, open source projects I've contributed to, like Kubernetes, have been really empathetic. It makes it easier to navigate imposter syndrome. So yeah, problem, do you have control over it? Nope. Okay, think about the action item, what to do, where you need to be. In the middle, what do you need to do in order to get to point B? And for imposter syndrome, for me, that was, if you don't understand this project, okay, I'll learn about this project. If I don't understand this technology, I learn about it, this and that, whatever. And if you get stuck, then obviously get help. Like Chris was mentioning in the previous talk, just get help, it's fine. So that's a bit slides. Documentation, this is very important. Has happened with me. So it's like three years ago, I was working at a company, it's no docs, nothing. And I was like, how am I supposed to understand? It's just, and he did give me a good tip. It's like, look at the test cases. I was like, yeah, that helps. But still, if you have docs. So ideally, if you're anyone who has their open source project they're trying to grow or contribute, so have good docs, and Chris, already emphasized on that. But if you are looking for people to contribute to your projects, have good documentation. Yeah. And write readable code. That's another one. So I see all the time, I see these, complex code bases that not really, it doesn't really make a difference in terms of the space and time complexity, but it's just super complex. So I think if you're writing complex code, at least comment it. I don't have to tell you what to do, but think about that you're writing code, someone else will read it. And since we're talking about leadership, then some of the finest leaders are the ones who remember what it was like to work their way up from the bottom, and who can foresee themselves in other people's positions. So last question, can empathy be taught? So if you think yes, raise your hands. Yeah, if you think no, raise your hands. Okay. Yeah, it can be taught because it's much more than a feeling, it's a skill. And just like every other skill, it can be taught. Some people obviously, have a natural talent, some do not, that's fine. Not a fixed trait that people are born with. But things you can do to incorporate it is listen actively, communicate effectively, and understand the emotions and experiences of others, which is putting yourself in other people's shoes that I talked about previously. Just a time to reflect, think about a time where a lack of empathy caused havoc in a project or work environment. Just think about that and see what could have been done better. And lastly, empathy, it does not require that we have been through the same thing, because that's where most people confuse it. They're like, I don't really get you because I can't relate. I have never been in this position. But it doesn't have to be that way. It simply means that you meet people where they are now, because this is one of the reasons why people ignore it. Oh, like, I don't relate, it never happened with me, so I can't understand. That's the thing. That is sympathy, I think, if you're sympathizing with someone. Oh, thank you. That's me. And thank you to Akanksha as well. And no other slides, I think. But yeah, it was good. Thanks for coming, and enjoy the rest of the Native Rejekts and KubeCon if you're coming to KubeCon. But I did give a lot of action items. I like to keep my presentations like a lot of action items. So hopefully that helps.
Questions? No? Okay. Thank you.
I'll be here as well.
Okay. Great job. Yeah, we'll be back here with more sessions after lunch. More sessions. Okay. Thank you.
No worries, no worries. As and when. Yeah. Yeah. So you're working on the video, yeah? Yeah. Fabulous.
So we're going to get started here in a couple minutes. Going to get started here in about 3 minutes. Welcome to the second half of the day in the VIP room. Ready to go? All right, come on in, have a seat. We're going to get started here. Our first speaker is Alessandro. Introducing progressive delivery with a bunch of really cool technologies. So welcome, Alessandro.
Hey, thank you for having me. Thank you for being here. I'm gonna talk about, it's a very technical talk. I'm gonna show the demo, and I'm very happy to be here. So I think for the first time in my career, I introduced myself. I'm Alessandro, and I don't need to say I work for, because I'm currently unemployed. So I can bring up my real nature, which is the cloud pilot. And I opened, a couple of years ago, I opened a co-working space, and I call it the Cloud Pirates, because the pilots were the freelancers of the sea, and we were the freelancers of the cloud. And I can tell you everything about the economics of piracy and democracy and everything. So reach out to me if you want to talk about these topics. So I'm gonna talk about the problem, what is progressive delivery, why you should care, and how to address the problem with technology, right? So that's That's why we are here, and that's what we love. But before that, some trivia time. Who knows what this is? This is a sunset on another planet. This is sunset on Mars, recorded on 2005 by the explorer, and it's blue. Why is blue? And any science people around? I love science. I'm a chemist. Why is blue? Yes, atmospheric pressure is 1% of Earth, and it's full of dust, and that's why it's blue. Second thing, this is my happy family, made of 5 kids. They just sent me this picture. They're in Amsterdam, and I have to do this because they always ask me to talk about them. These are my lovely children, 5 of them. So what is progressive delivery? So it's a technique to minimize risk. So that's the whole point we want to address here. Can be done in different ways, but the whole point is, and we know how costly is outage, how costly is not providing your user with the right features at the right time, in a timely manner. So you do want to introduce some sophisticated technique to introduce features in a controlled fashion, right? So it's all about control. It's all about making sure that your users see what you want to see at the right ratio and with the right feature set, and make sure that the right user sees the right thing. Why we need it? Because we want to minimize risk, improve user experience, have precise control, and especially because we want to be a data-driven organization, right? So we want to run experiments, right? So we want to make informed decisions on what's going on and not just have feelings, right? So not that feelings are bad, but they are not for a professional environment. So you need to understand what's going on so you can make a decision based on facts. And the facts are metrics, logs, real user measurements, not just feel like wrong or feel like it's right? So that's being a scientist. That's what we used to do in the lab. You can't just say, "Oh, I feel this reaction is gonna go." You have to actually measure with an instrument, right? So that's why we call it instrumentation. That's why projects like OpenTelemetry are so popular now, because they give you objective reality, objective numbers, so you can base your decision on. And what do you need to get there? And it's not an easy path. It's been around for a while, but we always wonder what kind of stack we need to get progressive delivery going on, right? So most importantly, I think it's the most important layer, is this smart load balancing thing, right? So could do it in different ways. I'll do it with Istio today, but there are plenty of tools out there. Still probably lacking good cloud native or cloud-based load balancing. I know Microsoft, Google, they have this smart load balancing layer, but most likely you want to do this in cluster, right? So in things like Istio or Cilium Service Mesh will give you this very accurate, very precise control of where your traffic is going and why, and based on what rules and so on. And you need weighted backends, right? So you want to know, you want to control exactly what part of that incoming traffic goes to which backend. And of course, you want to program this, right? So you don't want to be there and move a knob. You want the knob to go by itself, right? You want the knob to be automated. So, and of course, you want to instrument and do everything based on data. Canary, so what we're gonna show in the demo is a canary release. What does it mean? It reminds of the actual bears in coal mines, where they were dying fierce when the amount of CO, of carbon monoxide, increased in the atmosphere. So they actually use real bears in coal mines to alert the people that were working there when the bear is dead, means that the CO level is going too far and you have to get out of there. So that's the canary release. You introduce a new version of the application. It's going to receive some small amount of traffic, and then you're gonna watch, right? You're gonna experiment. You're gonna measure the impact of that change, version 2 or version X, measure it and make a decision out of it, and progress as all the signals are in place, things are going well, your users are not complaining, especially you don't wait for the users to complain, but you wait for the signals or the metrics or traces to tell you what's going on. I want to skip very fast because I want to get to the demo with one hand, of course, because I'm a pilot. I can do it with one hand. Another tool, so for this automation, you do need special tools, right? So you can't just do it with the regular Kubernetes objects. You need something more, right? So, and that more thing is, of course, is one tool that is part of the Argo ecosystem, right? So Argo ecosystem is pretty much loosely coupled tools, including Argo workflows, batch system, Argo events, notification. The king of the ecosystem, of course, is Argo CD. Everybody knows it. It's the GitOps tool of excellence, being in France. I can speak a little French. And what we want to focus today is Argo rollouts, which is a side project or part of the Argo family, which controls progressive delivery, which makes easy to control exactly this thing. So why we can use it? Because there is a new plugin. Argo rollouts is all about plugins to move these knobs. And there's a new plugin called about the Gateway API. If you don't know, the Gateway API is a project within the SIG network of Kubernetes, which will not replace, but will probably be a big change when you think about ingress in your cluster, right? So it's a kind of a unifying API for all sort of ingresses, including, of course, the classic ingresses like Nginx and Traffic, but also for the service mesh, because service meshes are also a big part of, they provide these ingress services, for example, like Istio. So Gateway API is like the common denominator for all sort of things about ingress in your cluster. So because of this Gateway API plugin for Argo rollouts, we don't need to care that much about implementation. We can just focus on one set of APIs, one set of objects that will make things work no matter which implementation you can use. In fact, like you will see in the demo, I'm not using any Istio-specific objects, no Istio gateways, no virtual services. We all love and care for those, but they are on the side now. We focus on creating Gateway API objects instead of implementation-specific objects. So that's how Argo rollout works, more or less. So there's a controller. Everything is a controller in Kubernetes, right? Some kind of routine that's always there and is watching for something to happen, specifically a rollout. It's a new API. It's the object that controls what's going on and where to send traffic. And so the rollout controller watches for these new objects, and when detects there is a new or modified object, changes the, creates these new deployments based on what you want to do, and also is the guy who moves the knob back and forth between the versions and between the two canary and stable deployments. And what is the knob? Is the HTTP route, which is an object within the Gateway APIs that contains the backend weights that we were talking about before. But it will be much easier to understand when I show you the demo. And this is just the same thing. So what is the knob here? Because of the Gateway API controller plugin is the HTTP route. So I think I'm perfectly on time, 10 minutes on the slides, and wish me luck. So everything is on this GitHub repo. You will see, of course, commits at 3 o'clock in the morning, but that's who doesn't do that, of course. So No, there are also more recent commits. So, first of all, we're gonna need a cluster, right? So, I use the amazing Civo Kubernetes service because it's a cluster in almost a minute. I mean, in my test, it's like 1 minute and 10 seconds. I think they can do better, but they definitely leave the other cloud providers in the dust, which is amazing. So I just create a cluster, which is, I create an IP address because I don't like IP addresses. I don't like to show things on localhost. I like real IPs and real DNS names. So that's why I always like to create like a public IP address and some DNS names so we can actually show some real addresses in the browser bar. So I create a DNS zone and so on. So I create a cluster. I'm skipping this because it takes a minute and I want to stare at the screen for a minute, but that's how it works. So it's just I created with, guess what, the best CNI at the moment, which is Cilium. Why not? I mean, it's there, so why not using it? I'm not using anything from Cilium itself, but of course I can always look at the Hubble UI if I want to see what's going on, but that's not for today. And this is the crucial step. So install the Gateway API CRDs. Don't ask me why it's not part of the regular, it's not part of the default objects of Kubernetes. I think we're just gonna live with this. So it's something that maybe we can ask our cloud providers to just install for us, but it's a step, it's a simple step, but it's still one extra step. Of course, all this stuff should be automated with Argo CD or GitOps or some other tools. But for the sake of clarity, I show it here. So, and then Istio, right? So Istio is installing the default profile. The only thing you have to care for, and because I originally, I wanted to also extend this demo to multi-cluster, it's not there yet. That's why I'm deploying multiple ingress gateways. One is for the ingress traffic coming from outside into the cluster, and one is the east-west gateway. Forget about that for a moment. It's just there. It's another pod that runs a gateway, but it's for a future. And there's another README with the multi-cluster, but it's not there yet. So today we focus on single cluster progressive delivery within the single cluster. That's why there's some extra stuff in there, but don't worry. The most important thing is that there's this annotation that you can put on the load balancer, specific from Civo. So the load balancer comes up and it got some specific IP address, specifically this one, which is mapped to my DNS zone, so everything becomes easier later on. Right, so then I want to see things, right? So I want to observe things. So what do I need for that? The classic Kube Prometheus stack. You can go about this in 10 different ways. I love the Kube Prometheus stack. You can see it deploys Prometheus, Grafana, the whole shebang, and especially, and you can see the values over here. So it's very, very vanilla. Just I like the latest version of Grafana, and I want to provision dashboards already. So without me clicking and pushing dashboards or adding dashboards later on, I want Grafana to come up and have all the dashboards I need right away. So that's why you can load dashboard from a URL, and I think I did this already. You can create extra dashboards with, of course, with config maps, right? So, okay, so now the monitoring stack is done. You can optionally install Argo CD, so these things can easier. I just add this step if you want to, and this is the thing, what we're talking about, which is, sorry, one end. So this installs Argo rollouts. 10 minutes, fine, okay. What are the values here? Not too bad, it's here. Elm values. Just I want the latest version of everything because it's a demo, so probably you do want to do this stuff also. Also, the dashboard is enabled, and especially this, I'm enabling the service monitor to be deployed. Service monitors are objects, part of the Prometheus stack API, which enable the Argo rollout controller to be scraped by Prometheus. So I don't need to configure Prometheus. I configure the Helm chart of the Argo rollout, so it deploys the service monitors. Service monitor. You see there's a bunch of service monitors already deployed by Prometheus, plus one for the Argo rollouts and one for the Istio component. So those enable scraping of those targets by Prometheus. Now that I have all Argo rollouts, and is a pod, of course, is running, and you can tell rollouts. So it's just a simple pod. Oh, come on. Yeah, okay, so Argo rollouts, just a simple pod. There is a controller, right? So nothing is happening, it's just a controller standing there waiting for my commands, like every obedient controller in Kubernetes. So what most important as well, so I need to add extra, because this is still not, of course, production ready. So there's a little thing that I need to add, which is this, is airbag role. So I'm just adding a few objects to the role associated with Argo rollouts, so Argo rollouts can actually do something interesting, specifically changing, creating, and changing HTTP routes, TCP routes, and so on. So that's it. Now that everything is set up, I can deploy the plugin. The plugin system for Argo rollouts is based on config maps. So there's a small config map that you put in a very specific place, and you give the URL of the plugin to download. It just works, and then you restart basically you restart the pod, so the plugin is picked up. So that's very simple. It works. And what's next is well, now I want to see this stuff that I just deployed. Oh, so this HTTP bin application is not the one that I want to show, but I want to show that this is the magic of Gateway API. Didn't create a single Istio object. I'm just creating one gateway. And it's interesting because that's how it works. It takes some time. So there's one gateway, which is not even, so normally in Gateway API, when you create a gateway object, it creates a pod, which acts as an ingress gateway. In this case, because I'm using these addresses, I'm actually attaching this gateway object to an existing service, which is the Gateway API, ingress gateway that I already deployed. And so this catch all ingresses, because I'm not specifying a URL, so it takes all URLs. And then the HTTP routes, this is also the separation of concerns that is at the core of Gateway API. So a system administrator, cluster administrator will create the gateway for you, and you, developer, with access to, for example, the HTTP bin namespace, are free to create your HTTP routes and attach those to the gateway that will provide the ingress. So, for example, and this should work, if, of course, Safari, because Safari always, yes. And so you can see that Gateway API works. Now, let me skip a few things. So also, Grafana. See, works out of the box. I just deployed this, and all the dashboards are already there. So especially the Argo rollouts. There's no rollouts now, but the control is up. Right, so you can open all this stuff. It works, Prometheus, Hubble, and so on. Now for the actual rollout, right? So you get to create. Come on. I just realized I'm actually right-handed. So for the rollout to work, you need to create first the services and the HTTP route before you create the rollout object itself, which is this one. So these are simple in the canary services. So I'm creating two services, the stable and the canary, very simple. And an HTTP route that has two backends, which points to the service I just created. And then the rollout is an object, where is it? This one, which lists the canary and the stable, lists a strategy, in this case canary, and it lists the steps. I'm not doing any analysis, I'm not gathering any metrics too complicated, but it's there, the mechanism is there. And then basically it's the deployment template. So the rollout is meant to be a drop-in replacement for deployments. So let's see how it works. Still right-handed. And okay, so now I have the rollout, and I can, there's a nifty Argo rollout plugin for kubectl, so you can get, so now you got this output on the come on, on the terminal. You can see there are 5 pods of the stable release, the revision 1, and then you can go and check the interface. Now you can do this with the command line, of course, but what I want to do is to do it. You can actually also check. Of course, this is the application. It's version 1.0, all good. And then I just roll a new version. And so now, and you can do also this, watch. Yes, so this is the HTTP route. And if you see, the weight just shifted 30% to the canary release. So, and now it's slowly going through this to the paces and executing your idea of a progressive delivery. I don't know if I want to wait until it finishes, but when it finished, the interesting thing is that these things are going to be swapped. So you're going to see that the stable server is going to wind down to 20 and then 0, and then the stable will be 100%. So automatically switch off, will switch again to the, because now what is canary now is going to be stable, right? So once the progressive delivery is done, then the canary is promoted to stable, and the old version becomes the old revision, and the next one will be the next canary. You can see now, see the switch? I catch it just in time. There are more things in the demo, of course, but we don't have time to go through everything, but there's an interesting workload ref when you don't need to, we can have a deployment already and refer that from the rollout, and you can also do some interesting stuff with the HTTP-based headers. So, yes, almost done. It went smooth. Surprise, surprise. So, first of all, so some resources out there. There are excellent articles, great articles from our friends and my ex-colleagues as well. So check it out. We stand on the shoulder of giants. I don't see Nick Young, but he's the guy behind the old gate. Not the only one, but definitely the Gateway API person, if you want to know more. And especially Costis with amazing work on the Gateway API plugin for Argo rollouts. Thanks, everybody. Thanks to Sivo for the infrastructure. Amazing. Cluster is in less than a minute. Thanks to Marino for the tips. And if you, first of all, kubespace.io is what I'm working on. By the way, I have extra stickers also from the tag application delivery, which is something I do. And if you don't have anything to do on this Tuesday, you can see me spinning at House of Cube, which is a great, so for the first time, I'm not speaking at KubeCon, I'm DJing at KubeCon, which is pretty cool. Right, any questions? Yes.
I know very little about service meshes, so this question might be dumb. But you already mentioned that you're working on a demo for multi-cluster. So what you could do with multi-cluster would also be automatic promotion of workloads from dev, staging, prod. Do you think this is a possibility similar to maybe what Captain or Cargo are doing today?
I don't know Cargo, actually. I know where it comes from Acuity, right? That one. So I cannot tell right now. The thing is, so I was exploring the multi-cluster thing and doing Istio and Service Mesh and Cilium, of course. They do a lot of, they are meant to solve that problem of multi-cluster. The thing is, I wanted to do it with Gateway API only objects. And I could not find exactly how to do it because I wanted to stay away from Service Mesh specific APIs. Couldn't make it. I have a year or 6 months before the next reject, so.
Any other questions? All right, thank you, Alessandro.
Cool.
Yeah, I'm here. Can you hear me? You should be able to hear me now. Yeah, I can hear you good and clear. Yeah, can you hear me? Can you hear me? Yeah, good. Let's talk to see what's going on. Okay. Yeah. Yeah.
So let's go ahead and get started. I'm going to introduce you to Patrick Stevens and Phil Wilkins, only one of which is here with us in person. So welcome, and let's hear about FluentBit.
Thanks. Yeah, so I am Patrick. I'm here in person, and my co-presenter can't travel today, so he's joining us Eurovision style from the UK. So Phil, just say hi, just
Hi,
to make
everybody.
sure. Yeah, there we go.
Yeah, hi everybody. Sorry I can't be there.
Cool, we're all good. Right, let's dive in. So it's on you, Phil.
Okay, so behind what we're seeing today is really a message about chatbots. So let's talk about what chatbots is and what to us. The background really is that a few years ago, chatbots became a topic for a little while, and it seems to have been quiet. Now, it hasn't gone quiet because it's stopped, but it's very much a case of
Phil, we might have to just drop to me, I
a
think.
lot of the ops has become very standard, very common
I'll just
in
kill him.
practice.
Right, so obviously the connection wasn't quite good enough for that. So today we're going to cover ChatOps and specifically look at using FluentBit to kind of power it as the back end and do all the hard work. So what is ChatOps? So from a ChatOps kind of definition, it was, I think, collaboration with instant messaging for DevOps is kind of the sort of Wikipedia kind of definition of it. So the idea here is that you can alert in certain channels and then respond in the same channels. Try and speed up that kind of response, make it easier, more mobile, more friendly for people to use, much more easier to do on the move, and maybe a bit more inclusive for people who can't be sat at the desk all the time or have access to everything. So what do we need for ChatOps? So we need some kind of way of notifying of something and then picking up the response. And that's the kind of stuff I'm going to show today. So let me just get to the slides. There's a lot of things we can cover in ChatOps as well. How you can use AI in the future, lots of different things as well. For today, I'm just going to cover a very short little demo and how to use FluentBit to do it. So, in case anyone isn't aware of what FluentBit is, let me just kind of go through it and make sure my timer is definitely working. There we go. So, I'm a FluentBit maintainer, so I have been for a few years now. So I kind of wanted to cover what FluentBit is, for those people who don't know, and why we're using it. So FluentBit, right at the simplest terms, is a telemetry agent that works on telemetry pipelines. So we started out doing logs in a very much an embedded context, and because of that kind of low resource mindset and capabilities for FluentBit, we've been adopted by most of the cloud providers in the world. So GCP, AWS, Azure, Oracle, plenty of others all use FluentBit under the hood. You'll find a lot of agents as well for observability vendors, New Relic, a few of the others as well are all basically rebadged FluentBit under the hood. And we started out doing logs, but yeah, since, for the last few years, we've been able to do traces and metrics as well. And the core of a telemetry pipeline is essentially we can handle a large number of inputs, we can do some processing on it, and then we can send to a large number of outputs. So we're vendor neutral, it's a CNCF graduated project, all those kind of good stuff. Today, I'm going to focus on using the Lua filter as a way of doing ChatOps. So the Lua filter runs Lua code, which if you do any Roblox programming or stuff like that, you will have seen. It's also used in switches, loads of other places as well. Quite a few tools actually use Lua as a way of providing a nice kind of interpreted language front end into doing some very powerful processing. For FluentBit, we're all C, so we compile the Lua down with a Lua JIT into the actual runtime stuff. And FluentBit also does WASM, Golang output plugins and stuff like that, which is what we did for our commercial solutions. Where are we? There we are. So, how are we going to use FluentBit? So, for the demo today, I'm going to use the Slack output plugin and a dummy input. So we're going to kind of simulate an alert with the dummy input. The idea here is that we'd be thinking, say you've got FluentBit already deployed, forwarding your logs, your metrics, whatever. You can do a load of processing there to alert on any kind of output. There's various HTTP outputs, TCP outputs, OTel outputs, and then vendor-specific outputs as well. But for the purposes of a ChatOps demo, we're just going to be looking at how can we use Slack to alert and then act on those kind of alerts as well. To work with Slack, we've actually Phil put together a basic Java web server that talks to Slack, gets any kind of response as a Slack app, and then sends that response to FluentBit. So that's what that little Java bit at the bottom is. We also send via an HTTP output in the demo to that web server to tell them, oh, we've just alerted, here's the alert in Slack, make sure you watch it. And that's what it's going to cover. Come on, let's go to the next one. This is not going too well. There we go. Right, and how are we going to respond? So the idea with ChatOps is we can have a little bit of a discussion. We get an alert. In our demo, it's all going to be just in the channel. But if you're doing it in real life, like we do in Chronosphere and a few other places, you probably want to chat in a thread. You probably want to do things like direct your messages straight to the app. So you do like / and then the app name and what you want it to do. But in our case, we're going to do a quick I've got an alert. In this case, for the demo, we just generate a dummy one about permissions. But potentially it could be anything. You could scale up things in Kubernetes or in cloud environments. You could purge some logs. You could do loads of different things. And the idea here is that we're just showing you a nice simple pipeline for how you do it. So that Slack message is going to get picked up by the Java web server and then fed to FluentBit. And FluentBit then invokes the Lua processor as a way of doing all the hard work. So the big thing here is that kind of Lua code and the FluentBit pipeline showing you how to do it. So I just wanted to kind of highlight some of that. And that's pretty much everything there. So we have a little demo. I think I'm probably a little bit early for the demo, but we'll jump straight into it, and then we can talk through some of the code as well, potentially. So everything's in GitHub. I think I committed it late last week, and we can kind of walk through some of the stuff, and then I'll show you how it all fits together. So this is the Lua code, and this Lua code is intended to just run some defined scripts when it receives a command. The idea here is that when you roll out FluentBit, you can roll it out with a set of scripts or reconciliation actions, everything like that, well managed in GitOps if you want to do it that way. I kind of wanted to show you the power of some of the Lua stuff. In this case, we're just taking some HTTP input, converting it to the name of a script to run and a specific node, make sure we run it on that node, collect the output, send the output back. But you could do anything there. You could change it to do whatever it needs to do. You could build in some very bespoke kind of business logic. You could do lots of different things there, and that's what we see as well commercially as well. Customers can write Lua code quite easily, or Golang code, or templating, stuff like that, to do very complex business logic if they want to. We also have, I'll just show you a couple of other bits and pieces. So here's the compose stack. I'm just running a couple of containers, one for FluentBit, one for the web server. And it's all in the repo. And here's the operations config. So this is where we've got the input from HTTP. We've got, we're also capturing the output from the Lua scripts, which is getting forwarded to some local log files. We're running the Lua filter, and then we're sending all the stuff to either Slack or HTTP, depending on what it needs to do. So I'll jump into the demo. Let's get it up. So here's our Slack channel. Just ignore all that. We're just trying to wipe out all the stuff that we'd sent before. So that's the main reason that's in there. Let me make sure that's up. Yep. Okay, and then this is our repo up here. I've not really done anything. I'm just going to run the stack up. And then what happens when FluentBit runs up is with our dummy alert, we just fire it straight away at startup, but we only fire one of them, just to make it a bit more straightforward to work with. So there you can kind of see we've got our little alert come through on our FluentBit app. So there's a little bit of stuff in the repo as well around setting up tokens and things like that. But I'm not really going to show that because it's pretty straightforward. And then we can have a little discussion here. Phil can sort of talk about what he's going to do. And we can say, oh, I think, yeah, we need to fix this. So let's do that. Yeah, I think there's a bit of a delay on the Slack update. And in the background, you can kind of see, so it's a Java web server. It's a bit basic. It's just polling the Slack API. Really, this should all be event-driven, you know, in the Slack app. But the goal here wasn't to show a perfect Slack web server. So Phil's sending the command here. He's highlighting what he wants it to do. Send it to node 1, which is just the compose stack I'm talking about. Fix permissions, which is a script that we've already sort of pushed out to the node. It's all defined in GitOps, and it's kind of well managed that way. Okay, and then over here, where's my mouse cursor gone? You can kind of see the output from what it's done. So this is just sending it all over, receiving it, and then it's running it. And at the bottom, you can kind of see, if you look at the demo in the thing, we just echo the Tremod. But in real life, you could do a Tremod, you could do whatever you need. So the goal there, very much just to show you kind of a very simple way of doing a pipeline with Lua that can do various different things. It's potentially can be a lot easier to work with ChatOps if you're doing stuff in the same channel you're alerting on. We do it internally for stuff like deployments have failed with a couple of clusters or something like that. Do you want to continue? Do you want to fail them all over? Do you want to revert them? We do it with elevated permissions as well. People can approve it in the Slack channel rather than having to jump into 20 other different logins and find everything. So there's a kind of, in this demo, there's a set of prescripted actions. Maybe you could extend it to do other things. You could do all different stuff, really. I just kind of wanted to show you a very simple example of what we're doing here. So that's the demo. And then jumping in more into Lua stuff. So Lua, from me, as the FluentBit maintainer, was the kind of the focus of the talk for me. Phil was very much on the demo and some of the ChatOps stuff, as you may notice from my much lighter weight covering of it. But I wanted to highlight, for FluentBit, and FluentD as well, we provide a little sandbox there so you can mess about with input, write your own Lua, and see what the output is all live, and very easy to debug stuff and test it out before you have to deploy it in production and do debugging in production or anything like that. So Lua, certainly when I first started using FluentBit, it was a big concern for me around performance. It's an interpreted language. How does that impact when you're running, you know, in quite heavyweight production stuff? Do you want to do it there? All those kind of questions as well. We do use LuaJIT to compile it down, and to be honest, it's pretty good. There are some other things as well. You know, there's the maintenance cost of, you could have very simple filters all chained together doing each task, or you could combine it all into one large Lua filter, and it might be easier to maintain a nice bit of Lua as opposed to writing some very brittle and hard to maintain regex or something like that. But that's personal preference, and it might depend on the team as well. And also there is a little bit of cost if you're chaining filters together. So each one you do has to pack and unpack the data. So if you just do that once for one large complex filter, it might be cheaper depending on your pipelines than doing lots of little unpack and pack operations for a longer pipeline. We do have some WASM support as well. I don't really do WASM. WASM has been around for quite a while now, but I've never really tried it. And there's also any language that can output a shared library can write a custom plugin, so you can do Golang, you can do anything with LLVM backends. But commercially, yeah, we do quite a lot of Golang filters, plugins, all those kind of things as well for bespoke behavior. And the mandatory sales slide, well, not quite there yet, but so Lua modules is a way of, I don't know if anyone's used Lua before. There's a package manager called Lua Rocks, which is a good way of adding system dependencies. So you might think Lua, it's all interpreted, I can just write stuff and it will do it. I don't need to provide anything else. You can do that with some modules as long as you keep them completely Lua native. But quite often there's a dependency on a system library, libc, those kind of things as well. So you might need to consider that when you're writing stuff. I mean, it's the same with Golang as well. You can't necessarily always compile it all down to a completely static binary, but there are ways of doing it with Lua to make sure you only use Lua native components. But if you're deploying it and you want to take advantage of a system library that does, regex would be quite a good one. A lot of Lua regex modules rely on some system dependencies because it's just a bit faster than doing it all interpreted. So Lua Rocks is a way of doing that, and I kind of shown there's some Lua code, there's how you load it, there's how you run it as well. So if you want to use it in a container environment, just make sure you include any system dependencies you need as well. Oh, yeah, so here's the sales slide. I'll try and be quick. We just got acquired, Calyptia, by Chronosphere, and part of what we were doing was using FluentBit pipelines with various customers to collect data across different things. There's some custom input plugins, custom output plugins, but the big bit in the middle was just some Lua, we call them Lua processing modules, but the idea there is we've got a whole library of pre-built things for redaction, removing sensitive information, excluding stuff, adding stuff. Sometimes it's quite useful to add context, and quite often you also want to deduplicate, you want to do stuff just to reduce your Splunk bills or wherever they're going to in the end. Redaction was quite a good one as well. You know, from a security perspective, if the data never leaves the node, then it can't possibly be compromised as well. So I just wanted to kind of show that that's what we're kind of doing. But this is just kind of a glorified version of the previous open source one that we already have as well, which I kind of showed you there as well. Oh, and there's some jazzy. Here's what it looks like in the UI with the sandbox. I don't think this is very long, hopefully. But this is these are all the different Lua modules you can do out of the box. I think I recorded this the other day, so we tend to be adding them all the time as well. So I'm a really big fan of Lua now. I never really used it before, but it seems really useful and great to work with, and makes it very easy to write some complex business logic, which is always good. So, kind of the end of my presentation, a bit quick. Definitely on time, hopefully. So I just wanted to kind of talk a bit about what we're doing. There's a few links there. So Phil, my co-presenter, has written quite a few books. He's an Oracle developer evangelist. So if you want, he's written one on Kubernetes you can download for free. There's some training. There's the Slack there. There's some other bits and pieces. But yeah, so there's lots of things we could do to improve some of this stuff around security, maybe changing stuff, improving the server. But the goal here was just to show you a very simple pipeline that you can do input, Lua filter, do whatever you like, and then get an output. And there's all the references. So, any questions?
Hello, and thank you for the talk.
No worries.
I used to use the logging operator to do logging stuff.
Is that Banzai? I can't remember.
It used to be, I think.
Yeah, did they? I think they donated it. Yeah. yeah.
Are there any obvious reasons why I couldn't use this method to like forward stuff to Slack using the logging operator? Are you aware of anything? Or
No. So well, there is a Fluent operator as well. I mean, it's just config. That's one of the good reasons for using Lua is it is just config. It's not binaries or anything like that. So yeah, there shouldn't be any reason why. As long as, assuming the logging operator lets you define Lua stuff, but the Helm chart does, so I would expect the operator to do it as well. So yeah.
Thank you very much for the talk.
It's okay. It was a bit quick.
So my question will be about Lua and its limitations.
Mm-hmm.
So are there any limitations? And I will try to specify, can Lua code utilize more than a single thread, more than a single CPU?
On FluentBit, yes, as long as you use the new YAML format for specifying it. So in the YAML format now, you can attach filters to the specific input or output you want them to run on, and those inputs or outputs can be threaded and use their own threading for that. I would say, to answer your question about what can't you do, the big issue I'd say is system dependencies. If you introduce a dependency on the system that's not there, then you may see weird stuff at runtime if it just fails when it does a syscall or something like that. But usually that's quite a violent death, and you would probably spot it quite quickly as well. I'd say it's probably a bit better than WASM, which has a lot of sandboxing around what it can and can't do. So it might be better. But you can blow your foot off if you try hard enough, I'm sure.
Yeah, because Lua sounds like a big gun, and the problem is
so it runs,
not that.
Yeah, so we use a Rejekt, a separate open source project. We vendor it in and build all that. So there is an option to run in protected mode, which is the default, which tends to try and prevent a lot of the problems that you would have. But maybe there might be a performance hit, and you might want to run unprotected or whatever. For some reason, you might want to really say, please blow my foot off. And yeah, you might be. It might go wrong. I can't say it won't.
Because there was a problem with Lua in Ingress and Jinx that you can use Lua script to steal the token by reading from the file system.
Mm-hmm.
So probably it can. So the FluentBit can be vulnerable to it also.
Yeah, I don't think necessarily that's a Lua problem. You could get FluentBit to just print out all its tokens or anything. But there's probably ways of mitigating it and preventing those kind of problems, yeah.
Okay, thank you.
The delicate balance between a feature and a vulnerability.
It's always a feature. It's just how you use it, yeah.
Any other questions? All right, thank you so much.
Cheers.
Our next talk is at 4. So we have about just a little under half an hour. Feel free to grab some refreshments from downstairs, etc.
right. Welcome to my talk. Will ARM be the new mainstream in data center? So yeah, one word to myself. So I'm Toby, working for KubeCon since mostly 6 years, near to. So, and yeah, see a lot of common faces here. Nice to meet you all. So, hi. And yeah, working with containers since 7 years, and I'm happy to talk today about a new technology what I discovered for myself by switching from Linux back, or not back, switching from Linux to Apple Mac. So for me, I love to use Linux Mint. I was really in favor of it, and I had a lovely Dell XPS laptop, and I was really, hey, that's cool. But I still had issues with battery, and this really sucks, and I get annoyed, and I get older, and I don't want to play around anymore. So I heard about this new Mac M1, what is basically here, and there I discovered, okay, ARM on the desktop could be interesting. So I decided to switch over and moved also my whole environment to it. So, and I thought, okay, let's give it a try because it's new. Will it work? Like, also will it run with x86 apps and so on? But it's an objective result. So if you see it different, feel free. But it's my personal result was a battery is awesome. You will survive a conference, a train. So I know KubeCon, first time I didn't charge a laptop at all. I would never give a talk with my Linux laptop here without battery. So this was something what was really awesome for me. Then performance. Like I intend to have a lot of tabs open. I don't know who else, but like a lot of windows, a lot of tabs, and every time oh, please Chrome, don't crash. And if I need to reopen it takes 10 minutes and right before of a meeting. And this was like really helping me because now it starts really fast, 10 seconds around. That's really cool. And the device is cool, and there is no fan noise anymore. So basically, there is a fan included. I tested it. It takes really something to get it running, and that's really nice, and really enjoyed it. Then Corona came, and I enjoyed the battery again because I was moved out in a separate room because of my newborn, and there was no TV, so I used my laptop, also watching Netflix and so on, and yeah, whole day watching videos and still have like 20%. So this was really like, okay, that's really a game changer for me. And then I started to use other apps what I normally use on the old system or on Windows, and there Rosetta and Windows on ARM with Parallels really is also awesome. I did some flyers for like a local party, and this was an old Photoshop version on Windows, works with Windows on ARM, so I was amazed. But yeah, you will close a lot of applications, at least if you come from Germany, because in Germany, if you type it's the same combination in Windows, is the combination for the and in Mac it closes your Windows. So this was quite heavy. And you may get annoyed by extra cost for tools and help, but that's not much, but you will pay it. And it takes time to switch, at least for me, to get the shortcuts, to get a different look and feel, and get everything automation, like a better touch tool, for example, I can recommend to automate your workplace and how you move windows and so on. Okay, but yeah, and that's brought me to the thought, hey, why is ARM a game changer on the desktop? Could it be also a game changer for for server, data centers, and so on, as we're working with Kubernetes? I thought, okay, let's take a look closer. What is ARM all about? So ARM is, if we say, a simple set of instructions, what called RISC, and if you compare x86, it's called CISC. And basically, the main difference is it's a smaller set of instruction, and it has no direct memory access, so the data must be already on the chip, and then it can proceed really fast, and they have one basic instruction per clock cycle. Why is this fast and more efficient? I was thinking about the same if you're doing like things, like simple things more often, you can optimize it better, and that's the same thing they used. So basically they moved the complex stuff to optimize for the processor due to compiling phase. So if you're compiling something for ARM, it takes longer as it takes for x86. And so basically you think, maybe that's come to my point. Go and Java. In Java, you basically deploy your source code, more or less, to a runtime. And the runtime makes the mapping to the processor and to the hardware. And so the compile time is low, but the execution time is higher. And if you compare it with Go, you compile it already to your target platform before you're executing it. So you have the complexity on the build time. And that's why it makes sense for me. It's the same why we're using Go. You reducing the complexity and you reducing the speed. You have the speed in the execution and not on the compile time, because the compile time doesn't matter. And the power, the same thing. You make it more simple. You can more optimize your battery. You can optimize how the processor is interacting to reduce your power consumption. And that's what they did. So, and yeah, so what we also see is the pricing. Like not so complex chips means I can produce the chips more cheaper, and that's why they use often in IoT device or in mobile phones. At x86, mostly you're using for desktop and server applications in the past, but I would say it may change. And now, why? If you see here on the ARM website what is already supported or who is working with the ARM technology, it's quite heavy. So we at KubeCon also implementing and have implemented already ARM support, just not officially because we are not so good in going into official programs. But because we are a small company, that's why. But you see a lot of ecosystem is there, and also the major hypervisor are there. And this brought me to the thing, okay, let's inspect a little bit more. What are the promises? So maybe you heard, save energy, save power, but what exactly are the promises from like, so in this example, AWS say, yeah, you can run a broad set of workloads. So you can run application server, microservices, databases, and high performance computing. I was, okay, that's quite interesting. Then you have, you can optimize costs, so save up to 20%. Okay. And like the price only, like with, if you have the same CPU, same memory, you save 20% only on the instance cost, no matter what's running there. And sustainability goals, so up to 60% less energy. And you see energy will be more and more a cost factor, at least in Germany for sure, for all others in Europe maybe as well. But this is getting more critical. And yeah, what are people doing? So like Datadog, you know, Datadog doing monitoring, have a SaaS offering, a lot of data to process. So they're surfing now with identical number, of course, a lot of more customers. So that means really like you can scale your business, you can get more out of that what you're paying, and that's every month, every hour. And so that's, I think it's make worse to take a look in it. And then I searched further, and I was then really like surprised. Like Iris is like a data platform, however, what they are doing, but they have 40% better price performance to the performance, of course. So that's 40% what I can save infrastructure costs. And this was 2020. So I think now we are already more efficient, but they already started 2020 to move to ARM. So I was not expecting that. And then I found a post about Azure. So the ARM services get introduced in 2022. So in there they providing 50% better price and performance. Okay, that's all marketing numbers, but you see it quite, there's a chance that you're getting more performance out of your cloud cost or on-premise. And here, what is one take is Gartner predicts 2025, so next year, that top 3 criterion to cloud projects will be the decision how much energy or carbon emission you have. If you're thinking about that, it could make sense as you see like a lot of companies want to go green and want to go be reducing the footprint. And there was also some statistic that a lot of the energy what we consume are based on cloud costs or data centers. And that's why I think this will be a thing. But I'm like more statistic as marketing. So, well, then it depends. In IT, it depends every time. So be aware, statistics is just a snapshot. So if you want to make your own opinion, test it with your workload. But there are some, I would say, predictions, what you can see. So there, on a blog post, so if you download the slides, you find the link. They compared AMD and Intel with the ARM processor and with different benchmark tests. And there you see, like here really, like $10, I think it's per core, to $5 per core is like 50% what you can save. If you may running just one WordPress instance, okay, you don't care. But if you are, I came from the upper talk, how many cores was it? I don't know. 2 million. It may make sense to think about if I can save here resources. And same thing, layer stack saying, so it's the next big thing. We have twice the performance for the same amount of power and like half power needed for the same compute. And that kind of also makes sense on premise. If you think like on-premise data centers consume a lot of energy, you may need less machines, you may need less maintenance, so it will sum up a lot of costs. And that could be really something to think about if it made not sense also like for mid-sized companies already to take a look if I may change my data center to some ARM specifics. And how we can do this? Yeah, Kubernetes can help us because Kubernetes already abstracted infrastructure and already abstracted also the platform underneath. So basically, I would say Kubernetes is more or less now the cloud native operation industry standard, like a cloud OS. Whereas native, I can go to every customer and if they have Kubernetes, I understand what they are doing. And that's one of the big pluses what we have now. And if we go back, why was this successful containerization? So this brings us back to ship containers. So really, they have the same anchor points where you can move containers around, but they are different. Maybe the ARM container is more like an open top container, and the x86 is a hard top container. But it doesn't matter. We can use both with the same anchor points. And that makes sense. I can run the same stuff in different environments, just knowing the right interfaces. Okay, and then how I can achieve my target state, that problem is already solved with Kubernetes because with Kubernetes, we have infrastructure, what we say, hey, we want to run that one. The reconciler takes care that we run it, and then we reach the state. So this is already solved, so we don't need to solve this for ARM. But data centers, I know data centers are scary. Who running his own data center? Yay. At least, you know, there's storage, there's network, there's cable, there's backup, there's a lot of, yes. And we want to run it. And we have multiple data centers. And then maybe that's not enough because we are in a manufacturing, we have maybe edge devices where we read our sensor data or something. We have cloud providers because, hey, fancy AI, we need to have this, and all this must be consumed and managed. And therefore, we have to take, hey, we can scale this, and we using Kubernetes as standard for it. So we want to manage everything with Kubernetes, because if you know your ecosystem, you are be fast in doing that, you are fast in maintaining it, you can use the same kind of DevOps engineer for edge applications, for AI management and data centers. And with ARM, it's the same thing. So, and I thought, okay, let's evaluate this because, yeah, in theory, everything is easy. And now I started my home lab. So first thing was, okay, I do one serious empty cloud cluster. For that, we at Kubernetes have our platform where we deploy some monitoring stack, not much workload, but just to have really an empty cluster and see is they're already different. And here, what is different when I create a cluster, I just choose another node type. So in our case, it was on AWS, just use a different node type. And you see already here, $0.38 to $0.4 is already cheaper, the price of just the machine itself. And then I compared basically what is the consumption difference if I just have an empty cluster. So on the top we see x86. We have basically a CPU usage of 356 millicores, and we have a memory usage of 3 gigabyte. Okay. And on the downside we have ARM. So we have here 186 CPU millicores, and we have 2.6 gigabyte of RAM. So already like 47% less CPU and 12% less memory only by the simple node with 2 CPUs and 4 gig RAM. Basically what is running there are some Prometheus agents, Cilium, some helpers, I would say, basic infrastructure. So, and that was like, okay, surprising, but I wanted to get more workload in it to see it really how it behaves. So that's why I choose my home lab. And yeah, first I needed to find hardware, and my wife's laptop was like, oh, it's so noisy. I say, okay, no worries, I have another use for it. So I placed it in my new nice rack and put the cable on it, installed Linux Mint on it, and installed Kubernetes on it. And then, thanks to Kubernetes, I get one Raspberry Pi 5 sponsored, $110, so it's really nice. You can run it there, and now let's compare. So what I wanted to play there is I have mostly exact hardware, 4 CPUs, 8 gig of RAM. We installed there on each Kubernetes cluster, which is a single node, untainted with plain vanilla Kubernetes. I used Kube1. That's our open source tooling for if you just want to spin up a quick cluster, and deployed a home automation. So Home Assistant, Mosquito is an MQTT thingy, and Prometheus operator for monitoring, logging, and so on. So simple application, but I would say it's nearly close to something like what you see in the IoT space. So you have also there MQTT, you have some application to working on top of this data. Home Assistant has also data like included, where you have like really constant data flows, and that's what may compare it to a real workload already. So yeah, and what we then need there to deploy it is ARM containers. So may you think ARM containers are super hard to build? I can say you it's not, because it's already included in the OCI spec. So basically, you can just start with your current Docker file. You just need to build it on an ARM machine. That's the simplest way, and then see if it fails or not. But if you're using may not super, I would say super weird packages, or already it can just run out of the box. Or you can specify what I would prefer, the dedicated platform with the -- platform statement in your file, and then you can also use it. So let's see how this looks like. So it's maybe complicated with the microphone, so let's try it. So here we see now this Docker file. So simple Docker file from Ubuntu, and I specify here the platform ARM64. I say, yeah, basically install Apache 2 and give me an output, and that's it. And basically, if I now want to build it, okay, can you hear me without microphone? Is it working? Okay, I try to talk loud. Okay, then let's go there. So basically, here, if I just build my first simple image, it's basically just a Docker command. I know you have other toolings, but basically build the current Docker file, and there you go. So basically, I already built it before, but it's downloading the Ubuntu ARM image, and then it's starting to install the Ubuntu ARM packages, and everything runs. And I can now also say, okay, inspect, and this gives me the hint how it is working. So you see here the architecture is here ARM64. So basically the OCI standard already has the information what architecture you're running for. So this is really cool. And if I want to deploy it now for AMD, for example, the nice thing is with the Apple Rosetta integration, I can build their AMD64 containers and ARM containers on the same machine. So with Docker Desktop, they did a really great job. Basically, we can build both things. And if I now take a look here, in the architecture, I have AMD64. So that's basically how I create different kind of architecture images. But if you now will pull it, the kubelet or the container engine will not know what architecture it does. For that, you need to create like a meta manifest, what matches what container to use. And that's the next step you will need to do. For that, I would say I would build the image as more as I would do in work. So I have an architecture flag where I say, okay, please define the architecture I'm using it from, and I use the base image. And basically, I want to give out here hard-coded into the code what architecture I run, because if I'm running my own code, I may have different approaches, whatever, just proofing that have different images. And then I have wrote a small make file for basically get the input, and it does some magic. No, it just builds the image and runs it locally, and then I can show you how this will look like. So we have here make Docker run local, and you see then here now I have I can now curl, and I get an AMD64 container image. So now let's change it to some ARM. And we want to have something special in it. So we're building a new image, and I say also here 2024, so building a new image, and that's based on ARM. So I can now say architecture, ARM 64, make Docker run. Sorry. Okay, I need to stop this one first. Okay. Okay, now we're running that one, and if I curl again, I see, okay, I get now our ARM image with rejects. And that's how it basically works. And the same thing I can now use for Kubernetes. So for that, I now need this meta manifest. This meta manifest is also nothing what is really hard. It's basically just linking two different images with one meta manifest where you say, okay, this is two manifests or two images together bind. And if I now releasing it, I can say make Docker release multi-arch, and then I building both architectures, pushing it, and creating then in the very end step a manifest with the same tag and so on. And then it's get pushed now to Quay, and on Quay we already see then the image. So we have on Quay then here a web server AMD and web server ARM image, and this one. And this is basically not a real image, it's more like a meta manifest, what is referencing to the other two images. But I see here that I have Linux on AMD and Linux on ARM. So normally also the other tag should appear quickly. So the reject is 2024. So it may takes a little bit more time. But basically then you have a meta manifest, and you can just use that one to deploy. So, okay, now it's pushed. Nice. And so you see now the new tag, and we have here Linux on AMD, Linux on ARM. So that's basically then everything what you need. Basically that image you can run on ARM and AMD machines. So let's deploy this. Here I have a Raspberry Pi cluster. Deploy this on that one. I have a small statement as well. So you see it here. We just deploy the normal meta image as a web server example and exposing it. And the same on the top where I have my AMD. And then I basically I need the service, and I can curl my node here on the node port with that port, and I should get here my brand new image with ARM. So ARM Rejekts 2024 container, and on the top, basically the same. Where's the node IP here? And then the port. And here you see you're getting the AMD one. So basically this shows this is transparent Kubernetes or the containers manifest already abstracted. That's what I really need to do. All right. Cool. Then one thing more. So basically now we want to go now. Now we can take a look in on my home automation. So in the home automation that is running on two clusters, what you saw already, we have now the UI running in both sides. So you see here now I am producing today 29 kilowatt of power, and I have connected my my inverter to see the live data. Funny thing, if I ask the inverter from 2 instances, I only get part of the data regards Modbus. I don't know, I was not so deep in it, but it's if you just run one instance, what querying the data is fine. So here on the right side, I have Tybert. It's like a dynamic electricity power provider where I get the data. So both is running here on Kubernetes. I have one instance, that's the Pi one, and I have instance, what is the normal one. So it's quite similar data, and that's what I want to compare now. So the comparison on data is now what I want to show you. Here we have the Pi on the left, and right we have the, okay, IntelliJ got away, ignore. We have, in here we see already at what was surprising in the home automation that here basically the CPU is around 0. And here we have quite a lot of more stuff, so it's not much, but it shows already, okay, it's less. The most funny thing was I didn't change any of my Kubernetes manifest or anything of the code of the application. And that was out of the box working on both platforms. And that was really where I say, okay, that's really nice. And the next thing was then Mockito. This is like the MQTT broker, so more or less like where you get messages in and out. This is basically the same CPU usage, so I would say at least you will not use more CPU. And the last application basically is our monitoring, and this was really interesting, I must say, because here I really see a difference in the plain Prometheus stuff. I have around 0.1, and here I have mostly around, I don't know, I would say 0.25 CPU shares, and we have less memory. So we have here around 1 gig, and we have 1.5 gig. So it's not much right now, but if you compare it to the scale, if you calculate it up, it can make a huge difference by exactly the same workload, exactly the same application. And in the end, you already see it in the cluster. So that's then the cluster scope where you see have here 0.25 CPUs, and here on the top we have like 0.7, I would say, in the average. So it's already is like really a difference, and that's yeah, basically was my result. So I would suggest to you like do it with your own applications to get out your stuff. And here we see also on the CPU, it's still loading here 0.10, and yeah, here we will have 0.25. Sorry. So then last words. I'm not used to this microphone thing, but here in the slides you will also get the data. Here we see that the CPU is much less on the ARM side, so I really was surprised that it's so much already in a simple use case. So my final thoughts are, adaptation of software is already given. Like everything I tested out with Cert Manager, I tested out Ingress, I tested out all this self-helper stuff is already there, so a lot of stuff what you may use daily are there. You use ARM in these containers in Kubernetes. It's just awesome because it's super transparent. It just works. If it not works, you may need to find the image or need to build it by your own. But anyway, it's still easy because you have the interface already. But you need to test and evaluate per use case would be my recommendation. And I think we will get more ARM processors. Why? We have the growing use of Kubernetes, edge, and container technology, and we will deploy edge stuff in the same way as we will do it in cloud because of complexity. The same will be the cost saving if someone recognizes, oh, I can save, let's say, 20% of my cloud costs or something like that. People will take a look at this. And you get pressure, like use more energy, more efficiency. So this will be thinking, okay, how we can reduce stuff, optimize stuff, and this bring, in my take, ARM to the data centers. I don't know if we have still time for questions. Sorry, was the first time.
You could take a question, I think.
One, okay. Otherwise, I'm still around, so you can come to me.
You said that you did all of this on a Pi, right? On a Raspberry Pi. Have you tried using, the AceRock or any of the Ampere dev boxes where you could get a whole lot more CPUs?
No, I didn't.
I would love to talk to you about that.
I didn't.
Since the non-graviton one, every other one is made by us.
Okay.
So
yeah.
I would love to talk to you about that. So.
Okay, sure.
Just
no,
but I'm not here to plug me.
This was.
I was just curious. So it is only the Raspberry Pi. That's
currently
four CPUs, and you got such a big difference in this.
Yes.
Wow, that's awesome.
And I think it's in bigger devices will be much more. And to be honest, it was the Amazon Prime delivery what makes the difference. But for my case, yeah. Yeah, so, but I see a lot of use cases like we're talking to manufacturing companies who want to place such boxes to their manufacturing machines and so on, and there it may say need more workload. I think also AI stuff can run on that, so we saw also TPU stuff with that technology, but this will be the next step to explore this more. So, but yeah, I was really surprised that the small thing is like better in the performance and like as my laptop and.
Thank you, Tobias. Awesome.
Okay, then thanks.
You can just put it on the table. Daniel and Mikhail are next. Are you here? Come on up. On using GitOps to simplify cluster API provider management. Thank you. And
thanks. So my name is Daniel. I'm from SUSE, and he's my...
Hey, my name is Mikhail Fedosin. I'm a software engineer in New Relic, and our talk is called Using GitOps to Simplify Cluster API Provider Management.
I hope you'll enjoy it, because it's a new development in the CAPI scope, and it's quite useful in some scenarios.
Yeah, so you can download slides by this link. There is a short link, so you can take a photo. Okay. So yeah, in this talk we will focus on how we automated cluster API provider management using GitOps on a very large scale with cluster API operator. But before we begin, let's quickly recall what cluster API is. Cluster API, or CAPI for short, is a sub-project under Kubernetes SIG's organization aims at simplifying cluster lifecycle management. It offers a declarative interface that enables cluster creation, configuration, and management in a structured way.
So the stream don't have the your PowerPoint? Yeah, probably. We need to share something.
Can you just, can we deplug and replug the laptop to try?
Yeah, we plug in here.
Oh, sorry.
Yeah. Okay, sorry, some technical difficulties. So go ahead, Michael.
Okay. Yeah, so I stopped at what Cluster API is, and Cluster API provides a declarative interface that enables cluster creation, configuration, and management in a structured way. And Cluster API has a modular architecture where each module is presented by a provider. And there are 6 provider types for different use cases. The main one is called core, and it defines top-level abstractions like machine, cluster, machine deployment, and so on. Then we have bootstrap and control plane provider types. The first one is used to add in new nodes to the cluster, basically configuring kubelet. And the second one is for configuring control plane components like kube API server, kube controller manager, and so on. Recently, 2 new types were added to Cluster API. One is add-on provider type for managing essential add-ons like CSI drivers, CNI plugins, and also IPAM for IP address management. And finally, there is infrastructure provider type. And infrastructure providers include implementation, API implementation specific for example, AWS, Azure, GCP, OpenStack, even bare metal, and more. So they offer a way to interact with respective infrastructure for cluster management. And in general, each provider has a unique set of options that have to be set up. And finally, I need to mention that all providers are essentially Kubernetes controllers, so they implement the control loop pattern, which translates Kubernetes specifications into operations against the underlying infrastructure.
So generally speaking about those providers, it's something which you probably, if you used CAPI, you know already. There's a tool called ClusterCTL for modifying and applying those manifests internally. You don't see them, you cannot manage them, you can only apply them through this tool, so it's not entirely that helpful. And CAPI operator on the other side allows you to do so. So all those manifests become under your own management, and you can manage them with GitOps. It's all declarative, and it's all ready to be used. So swiftly, you're going to go to the next slide, Michael.
Okay. Yeah, so, and as Daniel said, despite the fact Cluster API provides, it defines a declarative interface for cluster management. Its providers are managed manually with the CLI tool Daniel mentioned. It's called ClusterCTL. And this is not very convenient if you have multiple instrumented clusters, especially if you customize them a lot. And moreover, since all these operations are manual and not tracked by any GitOps tool, users may see some negative effects of that. Like there is no way to control over what's going to be deployed on the cluster, no history of rollouts, no way to roll back a failed operation. And to address this issue, we created Cluster API Operator. This operator is designed to empower cluster administrators to handle the life cycle of copy providers with declarative approach. It aims to improve user experience in installing and managing cluster API providers, making it simpler to handle day-to-day tasks and automate workflows with GitOps.
Yeah, and on another note, we have a quick start guide, our book, which feel free to include, ask questions, open PRs to extend with functionality you think is needed, because it's the very beginning of that. We are always open to contributions to the project. So let's talk about operator features.
Yeah, let's go to the features. Yeah, so let's just, okay, thank you. And yeah, the operator features. And first, since this is an operator, obviously it leverages Kubernetes custom resource definitions, which defines declarative interface that reflects the desired state of your cluster API providers on your clusters. And after that, teams can easily define their configurations in code, which integrates well with GitOps practices. After that, all configuration changes can be version controlled, reviewed, and automatically applied through CI/CD pipelines. And this allows consistent and reproducible deployments across multiple environments. Then upgrades. And upgrades of cluster API providers can be hard because users have to synchronize versions between components, ensure version compatibility, and our operator automates this process by detecting version changes in the provider specifications and performing all necessary steps while adhering to the compatibility matrix. And this simplifies this upgrades process for engineering teams and works well with continuous deployment practices. Then the introduction of configuration API provides users with a rich set of options to customize their providers. Through this API, users can do a lot of things, adjusting feature gates, replacing images, I don't know, altering security settings, and more. And this level of customizations means that your providers can be precisely tailored to the specific needs of a team or to comply with an organization's policies.
Yeah, previously, if you're talking about ClassSTL tool, you deploy your infrastructure in the desired manner as you did. It probably happens from a laptop. You have your own laptop, first time you just start a ClassSTL, you go through quick start guide, you deploy a cluster. You modify the things and it's left as it is. Then you switch your laptops. You lose your credentials, you may lose your templates, or something else happens. Someone else wants to reproduce this. It's not possible. Operator allows you to do so because, well, we have everything declaratively, and during the demo we're going to actually deploy a cluster with all those things included, see the air gap setup, which is not possible with ClassSTL, and it's pretty easy to do with operator, thanks to clever config map model we have in place for this. Yeah, and we're gonna go through GitOps scenarios, upgrading your providers, which is much easier to do with those manifests in place, and the process is quite swiftly working there. And upgrading cluster, which is also possible, but I'm gonna do this in the demo because it's a simple Docker cluster in this setup. So let's go to the next slide.
Yeah, and I mentioned that I work in New Relic and we use this operator in our infrastructure, so I just want to quickly mention how we use it and for what. Our infrastructure is relatively big, so we have more than 200 production Kubernetes clusters, about 300 in general, as I remember, about 30,000 nodes, and we use 3 cloud providers at this moment: AWS, Azure, and GCP. For AWS, we use EKS, so we don't manage control planes there. But for Azure and GCP, we manage those control planes ourselves with kubeADM cluster API providers. And finally, all clusters are independent, so they exist in different accounts. That's why teams can interact with other clusters. And because of that, we have to deploy cluster API everywhere on each cluster. And managing it with clusterctl, yeah, it's a huge burden for us. And that's why we adopted GitOps to manage all these installations with the cluster API operator.
So to the next slide, in Rancher we also employ in using the copy operator for several reasons. First one is the native copy model, basically deploying copy infrastructure without any modifications and following up with upstream practices. Second thing, we also using our own Bootstrap provider based on Rancher Kubernetes Engine 2, allowing you to basically provision your clusters with that. And it also uses copy and operator as a means to deploy. It's very simple to do with the things we provide in operator. The only difference we have in terms of the operator deployment model, you will see this during the demo, we embed a single API type resource copy provider for all mentioned providers like core, infrastructure, add-ons, and other things, because we need to basically integrate those things with the Rancher credentials mechanisms and make integration with Rancher simpler thanks to this. And we also use Fleet as our GitOps management solution. I'm going to show this during the demo how it works with our operator. So let's probably give you some frequently asked questions. So is copy operator replacing for clusterctl? Well, yes and no. In some scenarios, if you want to try out cluster API, it may be enough for you to use clusterctl. But if you want to do those things at scale with multiple clusters, like Michael's scenario, operator is much better for this, and it allows you better management model overall. We are using clusterctl libs as to the second question, so everything you see in operator is also based on the upstream implementation of those things, and this means that all the solutions, all the previous work, and all the problems they faced and solved in clusterctl are also solved in operator, so it's safe to use both. Also, this means that sometimes if we have some issue, we have to implement the fix first in clusterctl and then use in operator, which basically helps both worlds. Difference between operator and clusterctl CRDs. They are basically two different types. If you install a provider or a cluster with clusterctl operator, clusterctl with copy operator, clusterctl won't know that it already has all the required infrastructure deployments in place and will say that I want to install it for the first time. But internally, it's more or less the same. They also have a same specification, same fields, but they don't allow modifications for the provisioned infrastructure, like deployments. You can specify feature gates, you can specify things in a declarative manner. And there are some minor ones, but it boils down to the use case. And yeah, we can upgrade providers. We can upgrade providers very easily, although we cannot currently manage cluster upgrades with what I have in copy operator. Although currently, as we are going through development, we are trying to make a clusterctl plugin for operator, which will allow you to do such operations. So that's mostly it. Let's go to the demo. Here's a link. I'm going to show it during the process, and you'll see how we can prepare a basic set of copy operator providers, provision a cluster after setting them up, upgrading the providers, and using add-on providers as a new cluster API provider types. I'm going to give mic to Mike. To help me out here. So let me quickly switch the window. So setup here is pretty simple. First, we're going to deploy our own cluster, where we're going to deploy a fleet and cluster API operator. So Fleet is going to manage our GitOps here. For the Git alternative, we're going to use Git, very simple thing. I'm going to copy those things and run them in background so far. So yeah, nothing fancy here. One thing to note, as per installation of Fleet, we have two charts, Fleet and Fleet CRDs. They both separated. That's all you need to install Fleet initially. You always can deploy a Fleet YAML with your installation to specify namespaces or cluster groups you want to manage with Fleet, but we're going to go through the most basic scenario there is. Yeah, we're going to create a user, and what we're going to do is replicate a typical GitOps process you might see in your company, but in a very short manner in a demo scenario, because we don't have enough time for this. I'm just going to commit to the repo directly without any pull request, without any CI. But you might expect that in your environment there's going to be a reproducible CI which will test for potential regressions before merging those things and applying the infrastructure with whatever GitOps solution you want to use. And the last step, we're going to deploy the copy operator. It's a simple command. You can find it in Quick Start Guide. With that, we're going to deploy Thread Manager as a prerequisite. You can deploy it separately, or you can choose your own solution. You just need to disable this in this scenario, don't specify. Yeah, let's wait for this to roll out. In the meantime, I'm going to start my K9S. As you can see, the copy operator is getting rolled out. And let's go to the manifests we're going to deploy. First thing is finally what is providers. Here we have a basic set of manifests for rolling out our copy infrastructure of version 1.6.2. As you can see, some things already are visible. We can deploy core provider, structure provider. All of those things are separate resources. You can manage them separately. For each one, we specify some overrides for the manager deployment, where we'll set feature gates required by the Docker to deploy their quick start guide. And also we are specifying config secret with some variables. Docker specifically doesn't require any sort of cloud credentials or of any kind, but we have the GitHub token, so we can pull things swiftly during the demo. It won't have any issue. This secret is very useful because imagine that's your local environment, but now it lives in the cluster. That's allowed for cluster admin to access those things only. So whatever or whoever else can be a cluster admin, and these people can reproducibly redeploy your infrastructure at any point in time. So yeah, things are ready. Let's quickly check how our Git looks like. So Git, we can sign in. As you can see, we have a repository created for us. That's where our Git repo is established, and that's where the Fleet is gonna watch for our changes. We're gonna open this Git repo. You can see the definition of this. So yeah, it's ready to be pushing. So first step, so let's deploy our providers. And push. Well, it doesn't know where, git init. So I think it's a different one. This one, I guess. Yeah. So now it should be good to go. And if we push and set the region, some things will start to happen. Push. It seems to me that we still have outdated. Okay. Yeah, so respec master doesn't match any. I suppose we might move to our recording of the demo in this scenario if that doesn't work out. So yeah, let's move to our recording in this scenario. I think I have it somewhere. Unfortunately, some issues with our Git deployment didn't work out, but it doesn't matter that much. Yep. So I hope that's going to be enough. I'm going to deploy the same, essentially, infrastructure as you saw in this demo. Well, unfortunately, it's not a real one, but yeah, Git repo should be established in a second. I'm going to move slightly further because we already passed this point. Yeah, and we are starting with looking into those providers we're going to deploy. First one is, I guess, the providers, set of providers we're going to provision here. Those are the ones. The only difference here, as you can see, is a lack of specified secret. It's not required. It's only required in this scenario for Git token, but the rest of the things are the same. So the next one we're going to deploy is a cluster. I'm going to shortly show the cluster here. It's a Docker cluster. We're going to get one with a quick start guide from cluster API. Yeah, version 1.27.3. So a node one pretty much, but otherwise nothing complicated. No cluster classes, nothing here. And we're going to deploy some add-ons. One of the features which our operator allows you to do is to override or specify a custom URL to fetch manifests from, so you can develop your own solutions for scenarios you need. Like those add-on providers is something that user is expected to develop themselves if they need or add, and we can specify fetch config and URL to provide some sort of location we can pull the manifest and deploy our infrastructure for this specific add-on provider as well. That's what we're going to do. Also, we're going to install Calico in our cluster as a CNI solution with a Helm chart proxy. And also, those instances are just the Valero installations in the second add-on provider, a custom one, which just deploys a Valero instance in your other cluster and child cluster you provision and establishes some schedule for backups. So, yeah. So we are committing our first set of providers. And as you can see in a second, those things should be provisioned. We have a look at the Git repo. Git repo just basically says that something was reconciled, some commit have changed. We can see some new CRDs installed. Operator related are here, so add-on, bootstrap, core provider, they're already installed. And as you can see, we already provisioned the first core provider for us. And this core provider is currently being reconciled, getting ready. This means that it already deployed your infrastructure for the core copy. That's the definition of that infrastructure provider, which is a Docker one. We'll get ready in a second as well. And once it is ready, we are all set up to provision our cluster, which is going to be this quick start. So you can see under the hood what is happening in the cluster. We are deploying those components in the real time. Now we're committing the cluster. So when it comes to a cluster, just commit and push, and the fleet will pick up your changes. Everything will be rolled out in a declarative manner as well. So the next step is probably going to be how are we going to upgrade our providers? As you can see, the cluster has been provisioned. Everything is ready for this. There are no issues with provisioning as well. It will become green. But imagine now we want to change our version of providers. Now we have 1.7 beta 1 for copy. And here I'm going to just upgrade to 1.6.3 from 1.6.2. Just a patch upgrade, nothing major, but still it's an upgrade of all the underlying infrastructure for the copy. And it's quite complicated scenario in the cluster case. For us, it's just changing the version of the manifests and applying them via GitOps or just kubectl basically in this scenario. It works very similarly. So we're going to commit those changes, and you'll see that manifest will be provisioned. During that time, we'll see how the operator manages the underlying infrastructure and how you can supply your own manifests for air-gapped installations. Because operator under the hood creates a set of config maps with downloaded manifests for it to apply in the cluster. And if those manifests are already present in the cluster, or you specify the selector in the spec of our provider for the manifest to be picked up from, it won't query any Go proxy or Git to pull them up. So the only thing you probably will require as a additional thing for rolling out in your air-gapped environment is private OCI registry. Yeah, here you can see the config map with all the manifests, this is for infrastructure Docker, namespace, custom source definitions. It was pulled. Those things look like so. You have core 1.6.2, 1.6.3, so essentially that was after upgrade. And if we reapply those things at some point, which you always can do, if you change manually something, you can always reapply those manifests and nothing will be lost. Then, yeah, it's all ready to be used without internet connection. So next step is going to be, we're going to deploy some add-on providers as a Helm and a Calico with that. Yeah. And a Velero as a custom provider for backup and restore solution. As you can see, again, there's just regular CRDs. You can check their state at any point in time. They're getting installed. Helm is getting ready right now. Velero is going to be ready pretty soon. And we can apply our next thing, chat proxy. And I'm going to, as I have pretty much a small amount of time, skip to the end where we connect to the cluster itself and check that everything we deployed previously is actually made some changes to the child cluster, which it did, as you'll see. Hopefully. Yeah, some additional provisioning for the Velero to work, but it doesn't really matter. I mean, the cluster is running. So if you have any questions, please feel free to ask. That's all for the demo. Yeah, that's all I have. And if you have anything to add, Michal. Yeah, you can see, by the way, the state of the cluster at the end of the day. So Calico was being rolled out, and some Velero instances are as well. So everything in GitOps manner.
Yeah. So thank you for coming here today. Let's stay in touch. Our operator repository is under Kubernetes 6 organization. We have a dedicated channel in Slack, in Kubernetes Slack, and our documentation is available as a book, so you can read and update. Thank you for coming here today.
I feel like I was pretty on top of the Cluster API project, and I didn't even know there was an operator. That's a really cool project. Right? All right. You next? Next, we're going to hear from Timo. Timo, are you here? Right. Our next presentation is the magic of backing service provisioning with and consumption with Timo Salm. Welcome.
To my session today about the magic of baking service provisioning and consumption with cross-plane and service bindings. So my name is Timo Sam, and I'm a pre-sales specialist for developer experience at Broadcom after acquisition of VMware. And I'm responsible for our internal developer platform products like Tensor Application Platform and Azure Spring Apps Enterprise, which we jointly built together with Microsoft, and also our commercial Spring products. So actually, for a lot of organizations, the modernization of their software towards cloud-native applications is a huge focus or top priority. I hope I don't have to do that too often. But yeah, so actually it's a top priority for a lot of organizations to modernize their applications towards cloud-native applications to be able to grow their business by, for example, shipping software faster and reducing risk. With, for example, being able to be at the market early and also actually, validate their assumptions of the applications. And yeah, so with all those benefits, those cloud-native applications and the modern infrastructure provides, the missing separation of concerns and also the fact that there's a lot of cognitive load for the developers especially is a huge challenge for a lot of organizations. Nearly 1 year ago, Kelsey Hightower actually wrote the following. So for him, it's like the future, even if we're somehow there with some of the platforms, it's really that the developers, like in the past, only have to focus about writing production code, so really providing business value, and don't have to care about all those infrastructure specifics, and just provide some little configurations, policies, and configure dependencies like, for example, baking services. And that's really also the current trend of platform engineering, so providing an internal developer platform in the organization so that developers can refocus on really providing business value with the software. So actually, this is also what we're focusing today in the session. So it will be really hands-on, and I would like to show you really one of the core features of an internal developer platform, which is the interface. So not talking about a user interface or general user interface like, for example, based on Backstage, what we see a lot, really about the interface for developers to request all the infrastructure and services they actually need for the applications. So really a self-service for baking services. And if we have a look at the CNCF landscape, we can actually see that if we scroll down, that, at the category of provisioning, there are several solutions available. So like, for example, one that I guess everyone here is aware of, Terraform, or others like, for example, Ansible. So there are already a lot of tools, but today we want to focus on another tool, which is in the category of orchestration and management, which is Crossplane. What actually Crossplane provides or is really like, it enables us, so developers and operators, to define, provision, and manage services, so baking services, but in general, any infrastructure with ease based on Kubernetes. So it's really based on the foundation of Kubernetes, so all those concepts like controllers, etc., that you define as a desired state, and the controller will try to actually get the status of the running resources into the state. That is what Crossplane does for you. And really the focus is not only about resources that are internal to Kubernetes or Kubernetes native solution. It's a lot about external resources that are not into the Kubernetes ecosystem and world. And with that, also the main focus of the vendor of Crossplane, so Upbound, is really providing, for example, management of AWS, Azure, and GCP services so that you can manage all of them via your Kubernetes way, which is really great for people that have a lot of expertise in Kubernetes. And what it also allowed, what makes it even more valuable, is that you can create your own custom Kubernetes APIs, so CRDs, for your so-called managed resources. So with that, you can really abstract away a lot of configuration for the users of those provided services, like, for example, developers. And what I'd like to do with you now is really go step by step to the different building blocks of Crossplane and show you how you can create such a self-service offering for developers based on a PostgreSQL database. And we can see here on the diagram on the left how all those different building blocks are working together. We will start with a provider. And actually a provider is really a building block that actually packages or enables Crossplane to provision infrastructure on external services, like, for example, public clouds, but also there are provisioners available, for example, to execute Terraform, or then also apply Helm charts or Kubernetes resources, just that you have one tool to provide self-service capabilities to, for example, developers. And if we go here to our terminal and have a look at our provisioner. Sorry, this. Okay, maybe I'm too stupid to write it now. Sorry for that. But actually, it's like in my current environment here, I have a provisioner for Helm, one for AWS, and also common other services. So, and with that, what it does, the provisioner, it provides, in addition to those controllers, it also provides all those so-called managed resources. Actually, the managed resources are CRDs for the different types of infrastructure we want to provision. So like, for example, in our case, we want to use a Helm provisioner because of the fact that it doesn't take too long to provision such a service. We have the primitive of or the managed resource of a release, because usually what you have is that you want to create a release of a specific Helm chart. And we can also have a look at it. So as I said, it's a CRD. Let's run kubectl get. Yeah, it was providers. Sorry, it was providers and not provisioners. So here they are. Sorry. We have one for AWS, as you can see, and also in the past there was one huge provider, and there were a lot of CRDs, as you can imagine. And it's like, and nowadays it's a little bit more modular. You can see I have a provider here for EC2, but there's also one for RDS, for example, installed here, because that's the main purpose of this environment here, to really provide baking services. And you can also see the one for Helm. And what the Helm does is that it's providing a CRD for a release, which I can also easily can have a look at here. So that's the CRD, you can see it. And if I have a closer look, I can for sure also have a look at the CRD, at the YAML file to see via the Open API specification which actual configurations I can apply. If we go to the code, we can also directly see an example here, which I built. So you can see I set a name, and then I define the provider. For the provider, which chart I'd like to use. This example here is a lot less opinionated than other resources, because with other resources, let's say, for example, an RDS database, you know, or actually the provider has all the implementation to get the credentials and provide them in the proper way. Which is also something Crossplane really nicely supports. In this case, because any chart can be different, there's no real standard. It's like it's not that opinionated, so we also have to add some additional capabilities, like, for example, where we get the required credentials from, which we'll see in a second. The only thing I want to define here is the value of the persistence, so 1 gigabyte, which I will do via the values here. So that's really something special to the provider. If I apply it, I can easily see that it creates all the required resources. In this case, what's defined in the Helm chart. In this case, for example, the ingress, the service, the pod, the persistence volume claim. So everything actually this release needs. So we can see it's already applied, synced, and ready. And with that, we can also then see the resources that are deployed, like the stateful set or the pods. So it's starting, because for sure it takes some time to start a database, but actually everything is there, which is really nice. The next question is, so we have an application. In this case, it's just a sample application of me. And what it does, it's actually running, in this case, on Knative to make it as easy as possible to deploy. Knative is a serverless platform, also part of the CNCF, running on Kubernetes with auto-scaling capabilities, but also providing high abstraction so that you only have to define a container image. And with that, it automatically creates an ingress service for you and other capabilities, like, for example, revisions, etc. The sample application currently have 3 instances, and as you can see, it has an in-memory database based on H2, and on every instance, I have a different emoji here. And now I want to get them all together, and for that, I need a persistent database, actually. And the question is, how can I do that based on the information I have? And if we go back to our terminal and have a look, we can see that there is a secret, but the secret only includes the information required for our Helm chart, which is, or the database, which is actually only the password. So as you can see, it's only the Postgres password, which is the password of the Postgres, or the default user, which is for sure not enough to actually connect our application to this database. So usually a lot of more information has to be provided by the operators to the developers to get it working. But with Crossplane, we're able to define and find all those secrets based on the managed resources. And if we go back, we can see how that looks like. So if we have a look here at the more advanced example, we can see, in addition to some additional configuration that I need, because I'm actually creating, so that's all just the Helm details, creating a new user called default. And the database, the reason for that is that actually with that, it's defined in the pod as an environment variable, and I can actually use this information, as you can see here. So what Crossplane provides is this connection details configuration. And then you can see that I'm accessing for these different resources that are created by the Helm chart, I'm accessing different configurations of it. Like, for example, from the service that is created, I'm accessing the port, or also the host, which is defined as an IP. I'm, from the secret that we saw, selecting the password. So previously it was only the PostScript password, but because of the fact that I'm creating a new user, there's also a password for this user, which I'm using and setting then the key for it. Also from the stateful set, I'm getting some environment variables, for example, the username and the database. And if I apply that, we can see that there is a secret generated with all the information I need. So now you can see I have everything there. So really great way to actually create all the information your application needs in one place. To actually bind it to our application, we can do the most easiest way of just using environment variables and mounting the secret, also mounting the full secret to the application. Which you can see here as an example. So I'm using the same container image, and then I have, for example, the Spring Data source URL, Postgres, the host, the port that will be used within that JDBC URL, and also the password and the database. Because of the environment variable, I will use env-subst here to apply it. Now, as soon as my application is ready, I can actually see the result. If you apply the right one. And now we can see if I rerun that get pods command that actually the next revision will be created with all the new env variables. So it takes some time to spin them up because this Spring application is not optimized for serverless runtime, which is for sure possible. But then as soon as the revision is ready, we should see the result. So as you can see, now we are powered by PostgreSQL, and we are actually connected with our application to the provisioned database, which is great. So now we have more or less everything that we need to provide such a self-service. But actually, it's like there's a lot of room for improvement because it's like, now the developers still need to know everything about the Helm charts, everything about how to deploy the application. So there's a lot of Kubernetes and special expertise for the Helm charts involved. So the question is, how can we optimize that? And fortunately, Crossplane provides a way to create your own custom resource definitions as an interface, for example, for the developers. And this is what's done by a so-called composite resource definition, so XRD. This really defines the interface of a so-called composite resource, which is then at the end the resource you can create as a developer and only have to configure specific configurations that are relevant to you. The rest will be served by the operators. And there's another building block called a claim. Because of the fact that composite resources are cluster-wide resources, a claim is a namespace resource, which is really great for namespace for self-service capabilities, because then you can really provide one namespace, for example, per app. A composition is actually the configuration of a composite resource, which then defines how a managed resource will be applied. And you can also, for sure, have multiple managed resources in a composition, and you can also reference other composite resources in a composition. And with that, you can really modularly build, or offer services that are actually not one specific thing. You can really provide, for example, profiles for different services that are common for a specific type of application, etc. Let's now have a closer look, because we also run a little bit of time because of those delays, how that looks like, so that we also have a few minutes for the service binding stuff. So if you go back here, we can see that, or how this composite resource definition looks like. It really looks familiar to you if you're aware of custom resource definitions, because actually what we define is a name, and this name is based on the name here, so the plural, plus the group. So that has to be always the same. And then we have different versions, even if it's not possible if you provide different versions to, in a way, break the API. So it's not possible to add additional required properties, and it's also not possible to change properties that are defined. And with that, usually the recommendation is, for example, to create new composite resource definitions for new versions. You can see in this easy example, we're just providing one configuration for the database, and that's the amount of storage that's required in gigabyte. That's our API. The rest is about, okay, which connection secret keys we want to expose in the namespace. And then there's another concept I already explained, is a claim. It's like in comparison to composite resources, claims are namespace scoped, so that with that, as said, it's a lot easier to provide a self-service for the full organization. If we have that, if we look at how a claim looks like, it really creates a CRD for it automatically. So that's this PostgreSQL database, which I defined here as an interface. We just provide the storage, and we can also, based on what Crossplane is adding, we can also define where the secret will be written to, because this is what we know if we want to mount it. This is how a composite resource looks like. So that's the X in front of it, as you can see here. So that's just a definition by me. It looks more or less the same. The difference is that it's not namespace scoped, and therefore, for example, we have to provide a namespace here. And then for the service, it looks the same. So just embedding it. And last but not least, we have one of the most important parts here. In addition to the interface, we need the actual implementation, which in this case is a composition. So it's really about multiple resources that you can define here. Like, for example, in our case, it's just the Helm chart release CRD, which we also had before, with all the relevant information that we need for the configuration. You can see that I didn't define the name in the namespace here, only for placeholders, because that's something I can actually change in a composition based on also the information provided by the claim or the composite resource. So you can see here are the connection details, it's all the same. And then we have so-called patches and transforms, where we can then change the information here, so really template those resources. Like, for example, here that I, because the Helm chart that requires the storage persistence capacity in gigabyte, that I just, or it's not specific on whether it's gigabyte or megabyte, and therefore I add it here because my interface is just about gigabytes, and for example then here with those transforms add the GI for it. See that I use the, for example, the claim namespace and set the namespace, the name, metadata name, etc., and a lot of more stuff, so really templating the stuff. Let's move to the next thing. Actually, so this is, if I apply all the stuff, we have our interface, which is working great, and this is what then the developer would do. And for sure, it's only the implementation of an interface. So you could, for example, provide it via UI. For example, a UI in Backstage, a plugin, and then underneath you have GitOps, where all those custom resources will be applied so the developers don't have to interact with it. That would be the best experience. But if you have developers that are in a way familiar with it, or you just provide them a Git repository for GitOps, they could also create this themselves, because it's like, as you can see, it's really focused on the stuff they should be aware of. Maybe you could also provide things like resource limits, etc. if it's about the application, maybe not the database. So if we have that, we have more or less the same experience than we saw before with the release, but with a lot better interface for developers. Yeah, the question is, or still the question that's unsolved is, how is there a way to even improve the experience? Because one challenge we had, I showed you, is I still have to be aware how the secret looks like and how I can mount it to my application to get it working. So that's still something left. And this is where we have a new technology, an additional technology, which is called service bindings for Kubernetes. So, and what it's about, it's really about a way of automatically mounting secrets, so direct secrets that have a specific format, or also so-called provisioned services to an application without having that to do that manually. So like, for example, you saw we mounted those different environment variables. We could also have mounted the full secret, and we have to define it in our Knative YAML. And that's something that's automatically done for you by the service binding. And there's even more. So because of the fact that those secrets are standardized, it's possible to use libraries like, for example, for Spring, .NET, there's also one for Python, that automatically recognize those secrets, that format, and set it to the corresponding Spring configuration properties. And with that, it's like, okay, here's my application, for example, as a Knative service or a deployment. Here is my baking service defined by my claim. And then I have the service binding, which I just reference the Knative service and my baking service, if it's binding compatible. And with that, I have a fully working solution, and I don't have to care about secrets and also not the details of the provisioning. And that's something I will show you in the last minute. So let's go back to the code, and I will just apply it and then show you it live. So here that's a sample. So I said we can also directly bind the service binding. So that's how a service binding looks like. So that's directly bound to the connection secret we have, but and the service. But it's also possible, and this is what I want to show you now, to make the actual baking service binding compatible. And in this case, I did it because it's what we saw before is that I'm able with a composite to modify actually the different resources that will be the managed resources, properties of them and templating them, but it's also possible the other way around. So I can also, as you can see here, change so the two composite field paths. I can also, based on information I have, change the composite resource. And with that, for example, automatically set which the secret name where the binding is available. And also, as you can see here, because I extended the CRD with status here. So that's what is part of this service binding specification, that you need a binding dot name with the secret name. I'm actually extended it here so that we have this status binding name set to the UID of the metadata, which is also then set to the spec writing connection secret to ref name. And with that, my interface is really like, because I don't have to define my secret anymore, storage 2 GB, the service binding to my service, and this PostgreSQL database, so the custom CRD for my interface. And my Knative app, I also don't have to define anything than the container image, because everything will be mounted automatically and set. There is this bring out bindings library that will be also automatically injected for you if you're using a Paketo Cloud Native build pack, so you don't have to care about this stuff. And yeah, I hope I get 1 more minute to just apply it and show it to you. And yeah, that's really the experience I wanted to show you. Minimal configuration from the user side, and all the opinions, etc., by operations are baked in. And with that, you can really focus on providing a nice interface for your developers. Okay, so let's hope everything works. 1 second. Sorry.
Sometimes the demo gods come for us all, you know.
Yeah.
I'll take this opportunity to remind you that after this talk, this room will be empty. We'll all go downstairs. There's a happy hour. I do want to remind you that that happy hour means that at 7:20, we're all out of the building, but we're here at 6:20 having a happy hour. All right? Are there any questions
Yeah.
while we wait?
Do we already have some questions? So in the meantime. So actually, until hopefully this one is deleted, what I can show you is all the samples are available on my GitHub account, so you can easily have a look at it. So here, that's the repository. Just Timo Salm is my GitHub account, and then crossplane and service bindings. You can see all the different steps. Also, the commands are listed here. So try it out yourself and yeah, have a look how it works. I think it's a really amazing experience and yeah, providing a lot of value, especially if you use other services than, for example, Helm, AWS services. You can really see the ease of configuration and that it works. Nothing works. it's not there anymore. Okay. So let's try to reapply it. Okay, so that's not a problem. Let's start. You can see that the database starts that I requested, and we can also see whether there's service binding. So that's the one I was trying to delete, but let's see whether it will, based on the available service. We'll come back in a second. We can also see here is the out-generated service with a name as a secret, providing all the information. And what's special about the secret is that it also has a type like PostgreSQL. This is how the Spring Cloud bindings library knows that it's PostgreSQL and how to set it. And the provider, which is optional. And now we have a look at the service binding. We can see still service not found, but should be also something then based on the service that should work, even if I'm not able to delete it currently. So this will then actually inject the information because of the fact that my PostgreSQL database, so that's the composite resource, has this status binding name. So that is where I'm binding to all the information with the secret that it needs. And with that, it, as that, mounts the secret to the Knative service, and I have everything I need. Even if it doesn't look like so, usually it was really stable, the service binding, but it looks like I'm not able to get rid of it anymore.
Well, thank you.
Yeah, thank you very much for attending my talk and also the additional time. Yeah.
Thanks for the talk. Can you just describe, or why not, the Helm release? Yeah. I just want to see the status of that resource and see what's inside of it.
Yep, I can show you that. That's the one here that's created. And as you can see, I also added this additional postfix here, so that, because it's not namespace, it's not namespace scoped. Yeah, so what did you want to see? Actually,
I was wondering if you have the secrets or information about the secrets.
That's the only thing I define here is write connection secret to ref. This is what I also generated. So here's the name, and usually the convention is to set this, so it's in cross-plane, all the secrets from different managed resources, you can combine them and also define them, and then those will be put together in a global secret where everything is embedded that we define, and then you can, based on, for example, what I showed, based on the composite resource definition, define which of those will be used by for the developers to put in the namespace. So that's something you can then define. So.
Thank you.
Okay, perfect. Yeah. What is that? So all the code is available, so you can have a look and also then have a close look how these secrets are defined.